Since the mid-1920s, Douglas has been a prominent name in the world of aviation. Between 1922 and 1997, the Douglas Company, then the Douglas Aircraft Company, and then McDonnell Douglas produced aircraft in all shapes and sizes. Some have become immortalized in the halls of fame, like the legendary DC-3. Some were hugely innovative, contributing much to the field of aeronautical engineering, like the XB-19. And some? Well, some earned themselves a bit of a poor reputation due to a combination of questionable design choices, near-criminal executive decisions, and some appallingly bad luck. Many more are simply not well known, or more or less forgotten, but each of them plays a part in the Douglas story. But it isn't all just about the planes though. Today's special extended video will cover the history of Douglas in general, the history of the company's founder, and how the company fortunes were not just shaped by the successes of its aircraft, but also by world events, politics, finance, and the ever-competitive nature of the aviation industry. It also includes about an hour's worth of content that was originally cut from the 3-part History of Douglas miniseries I made about a year ago, as, at the time, I had concerns about running times on my videos. But as it turns out, my wonderful viewers are not afraid of long, informative videos, so I've picked up everything from the cutting room floor to create this special director's cut, as it were. Additionally, as a quick aside, this video will not cover the history or the aircraft bearing the McDonnell name, as that will be coming in its own dedicated video in the future. So, let's start at the beginning with Donald W. Douglas. He was born in Brooklyn on the 16th of April 1892, the second son to William Douglas, who was an assistant cashier of the National Park Bank. He received his early education at the Trinity Chapel School in New York, and then at the age of 17, having developed a love for the sea, he followed in his older brother's footsteps and attended the U.S. Naval Academy at Annapolis in the autumn of 1909. But as history is about to tell, his time with the Navy would be rather short-lived. Douglas was already developing a fascination with aviation. He was enthralled by the flying machines of the Wright brothers, and the reports of those being built in Europe as well. As a result of this fascination, he spent much of his spare time building model aeroplanes. Some were powered by crude motors, and others by rubber bands, and he could often be seen testing them on the open grounds of the Naval Academy. The result was that in 1912 he decided to resign as a midshipman before graduating and pursue a career in aeronautical engineering. Now in later years, some of Douglas's friends would claim that another motive for him leaving the academy was that one of his model aeroplanes almost took out an admiral who happened to be walking the grounds one morning, which led to some understandable drama. But Douglas himself repeatedly denied this story for his entire life, so it's difficult to say how much truth is in this particular tale, but regardless it has become part of the Douglas myth/legend. After leaving the academy, Donald Douglas attempted to obtain his first job in the budding American aircraft industry. He applied to work with both Grover Loening and Glenn Curtiss, but both of them turned him down. This did not put him off though, and he enrolled as a student in aeronautical engineering at MIT. Among his professors was Jerome Hunsaker, and I apologize if that was pronounced incorrectly. He had also been to the academy at Annapolis, but he had actually graduated, and he would later go on to serve as the chief of the Navy's Bureau of Construction and Repairs Aircraft Division. Hunsaker had created the nation's first aeronautical engineering program at MIT, and after Douglas graduated with his diploma in 1914, he remained on as Jerome's assistant for just over a year. But Douglas soon tired of teaching aeronautical engineering, as he actually wanted to actively do it, and so in 1915 he left MIT to join the Connecticut Aircraft Company as a consultant. There, he assisted in the design of the DN-1, the first dirigible for the US Navy, but his stay at the company would be brief. In August of the same year, he joined the Glenn Martin Company as chief engineer, and he worked on a number of their designs.
Most notable was the MB-1 and its derivatives. Now, the MB-1 was the first purpose-built bomber produced in the United States, and Douglas also had a hand in designing some of its subvariants, such as the T-1 or GMP, which was a transport version, and he also designed the TM-1, which was a navalized version. Of these, the T-1, the transport version, held his interest the most, as Douglas was among a group of emerging aircraft designers who was beginning to grasp the future importance for commercial aviation. But as fate would have it, his ambitions in this department would not actually be realized for a great number of years.
Douglas enjoyed a very successful 4 years at Glenn Martin, where, as chief designer, he was earning a salary of $10,000 by 1920.
He was also now a family man. As the Glenn Martin Company went through a consolidation in 1916 to form the Wright-Martin Company, Douglas had a brief stint as the Chief of Aeronautical Engineering at the Army Signal Corps, during which time he met his future wife, Charlotte, in California. By the end of the year, he was back working for Glenn Martin again, and the newly married couple resettled in Cleveland, Ohio.
But by this point, he was more eager than ever to break out and start his own company. His motives were both professional and personal. Though given a lot of flexibility in his job, Douglas did not enjoy full creative freedom when it came to designing aircraft. Additionally, his projects were dictated by the directors of Glenn Martin itself, and their views, though often similar, did not always align. As for his personal motivations, well, Douglas and his family did not enjoy the most comfortable or convenient living situation. They moved continually from one apartment to another. This was further complicated by Douglas refusing to buy furniture, as he had no intention of putting down roots. And because of this, the family often struggled to find fully furnished lodgings. And then there was also the weather. The Douglases pined for warmer climates, something that Cleveland, Ohio did not provide. Indeed, the winter of 1919 to 1920 was so bad that Mrs. Douglas took the children west to California. Douglas remained behind, helping Martin to try and find customers for their big twin-engine planes. But his determination to leave and start his own enterprise was growing stronger by the day.
In March 1920, Douglas travelled west to visit his family, and noted with regret how much his 2 sons had already grown in their brief months of absence. Reluctant to leave his family again, Douglas finally made up his mind about getting into the business of building his own aircraft, which would allow him to stay in California. At the end of the month, he wired his resignation to Glenn Martin, who tried and failed to convince him to stay. Leaving a $10,000 job in 1920 with just $600 in savings was a risky move, but Douglas was determined to design and build aircraft himself, and once he'd settled down in LA, he wrote to his old mentor, Jerome Hunsaker, and expressed his desire to find some investors. Douglas wanted to establish a company that produced commercial aircraft. He believed that California was one of the best places for commercial aviation to get started in the States, particularly as its climate was more conducive to testing aircraft rather than the often stormy and unpredictable winds of the East Coast. Hunsaker didn't share Douglas's optimism, and he suggested that Douglas go to Seattle and join William Boeing, something that Douglas outright refused to do. Indeed, the Douglas-Boeing rivalry is a topic that will get its own video in the future. But Hunsaker also lamented that the US Navy was being deprived of Douglas's skills in designing aircraft. And so, as a financial and as a moral compromise, as he still had to put a roof over his family's heads, Douglas continued to do contract work for the US Navy whilst he attempted to find investors for his own plans. A few months later, as money was starting to run out and as Douglas was beginning to give up hope for his endeavours, an old work colleague from Glenn Martin, Bill Henry, came in and saved the day. Bill had for a time been the advertising manager for Glenn Martin, and he now worked as the writer for the Los Angeles Times. He introduced Douglas to somebody called David R. Davis, a sportsman who had developed an interest in aviation, and, more importantly, someone who had quite a lot of money. Davis didn't share Douglas's passion for producing commercial aircraft, but he was prepared to enter into business with him, providing over $40,000 in capital, if Douglas designed and built him an aircraft, because he wanted to attempt the first non-stop crossing of the continental United States. Douglas agreed to this proposal, and on the 22nd of July 1920, the Davis-Douglas Company was officially formed. The nucleus for what would eventually go on to become the juggernaut that was Douglas Aircraft, and then McDonnell Douglas, had a very humble beginning, working out of a rented room in the back of a barber shop on Pico Boulevard in Los Angeles. In this cramped room, Douglas began the design work on the first aircraft that could be truly called his own. He was soon joined by 5 former colleagues from the Glenn Martin Company as well: George Borst, Ross Elkins, James Goodyear, Henry Guerin, and George Strumpel. At the same time as this, they had to find space to actually build Davis's aircraft, and the company ended up renting the loft of the Cole Planing Mill in downtown LA, and it was here that construction on what would soon become known as the Douglas Davis Cloudster began. The aircraft got its name from Eric Springer, who joined the company as its first test pilot, and, upon seeing the aircraft, he'd said, "My, you've got yourself a real cloud duster there, Doug," and the name stuck. The Cloudster was a fairly typical post-war American biplane, but one built with an emphasis on range. The airframe was constructed of wood, with the forward section of the fuselage covered in veneered panels, and the rest being covered in doped fabric. It was a single-bay tractor design that was powered by a 400-horsepower Liberty V12 engine that drove a 2-blade wooden propeller. Compared to other designs at the time, it had quite a large fuselage, and this was to house the 2 fuel tanks that totaled 660 US gallons, or just under 2,500 litres, as well as a 50-gallon oil tank as well. The combined fuel load was to give the Cloudster an estimated range of 2,800 miles, or 4,505 kilometers, and behind these tanks, almost halfway back along the entire fuselage length, there was an open cockpit which was wide enough to allow 2 people to sit side by side. Now, producing the components for the Cloudster in their rented loft was one thing, but building the aircraft there may have presented a bit of a challenge, as, well, it's a rented loft. As ripping the entire roof off the building and craning out a completed plane was obviously out of the question, the parts were taken in piecemeal and lowered to the ground floor via an elevator shaft, with the team collectively holding its breath as the delicate wings and control surfaces were gradually hoisted down. Once everything was on the ground in one piece, it was loaded into trucks and taken off to one of the airship hangars in Goodyear Field, and the aircraft found itself assembled by mid-February of 1921. The Cloudster's first attempt at its maiden flight was almost its last. The airstrip of Goodyear Field was quite short, and even though it was lightly loaded, Eric Springer was forced to abort the takeoff by intentionally putting the Cloudster into a ground loop before crashing into a copse of trees. Fortunately, the damage was quite light, and it was repaired in about 2 days. It then made a successful maiden flight on the 24th of February, with Eric Springer and Douglas Davis taking it up for a calm and completely uneventful flight that lasted approximately 30 minutes. Following this, Springer and Davis took it up for a series of test flights in March to determine the optimum cruising performance, and on the 19th, the Cloudster broke the Pacific altitude record by climbing to 19,160 feet. Finally, in June, they were satisfied that the aircraft was ready for the attempt to fly across the United States, and a departure point was set at March Field in California, with an arrival destination to be made at Curtiss Field in Long Island. As the first hour or so of the flight was expected to be quite slow, owing to the very heavy fuel load, takeoff was to be set at the crack of dawn to make use of the maximum amount of daylight as possible. For several days, the flight had to be postponed due to early morning fog at March Field, which was a seasonal event that delayed many a morning flight during this time period, but finally, on the 27th of June, the fog cleared early enough to allow a takeoff at 6 a.m. The flight began smoothly, and by midday, Springer and Davis were at 6,000 feet above Tucson in Arizona. But their luck then failed them over Texas. The engine's timing gear failed, and Eric Springer was forced to make an emergency landing at Fort Bliss. Within 3 weeks, parts had been sent out and temporary repairs had allowed the Cloudster to go back to March Field, but by this point, Davis had lost interest in making another attempt. Douglas, meanwhile, had secured a contract for the Navy to produce 3 torpedo bombers, which we will cover shortly, but Davis had no interest in financing military aircraft, or any other kinds of aircraft for that matter, and he withdrew his financial support within a few weeks. Without the financial backing of Davis, Douglas was forced to dissolve the fledgling company, and he once again turned to his friend Bill Henry for assistance. With the guaranteed partial payments supplied from the Navy for their torpedo aircraft, he only needed around $15,000 to launch a new company and begin construction on the military prototypes. However, Douglas was still a relatively unknown name in the aircraft industry, in the grand scheme of things, and bankers were not quite prepared to provide the needed funds. Bill Henry, on the other hand, had faith in Douglas, and he introduced him to his employer, Harry Chandler, who was the publisher of the Los Angeles Times. Chandler was interested in promoting new business ventures in Southern California, his journalistic realm, and he agreed to co-guarantee a bank loan of $15,000, if Douglas could find 9 other businessmen who were willing to do the same. Clearly, Douglas had some sort of a good reputation by this point, as he obtained the required business signatures within just a few days. The loan was organised, and in July of 1921, the Douglas Company was formed. Before we get into the history of the Douglas Company, though, there is still more to the story of the Douglas-Davis Cloudster. Having sat idle for over a year, and taking up some valuable storage space, it was sold to a couple of Californian businessmen. T. Kinney and B. Brodsky wanted to use it for charter flights above their Venice Beach resort, and they commissioned Douglas to extensively modify the aircraft for their needs. The extra fuel tanks were removed, and as the fuselage was big enough, accommodation was made for 5 passengers and a pilot in 3 rows of open cockpits. Though nominally rated for 6, on some occasions extra passengers were crammed into the first 2 cockpits, which technically raised the total seating to 10, though it was a bit of a squeeze. In the end, this business scheme didn't last very long, and in 1925 the Cloudster was sold on again to T. Claude Ryan, who was establishing an airline to connect Los Angeles and San Diego. The Cloudster began operations on the 1st of March 1925, becoming one of the first scheduled passenger lines in the country, but it only fulfilled this role for less than a year. During this brief time, the aircraft was modified when it had to be repaired after a landing accident. The pilot's open cockpit was moved forward to a position just beneath the wing leading edge, and a new enclosed cabin for 10 passengers was installed behind it. A test flight then showed that the pilots were quite literally being poisoned by the proximity to the engine exhaust fumes, and an exhaust stack was then installed. This was later followed by the installation of a new circular radiator to improve takeoff performance, and with these changes in place, the Cloudster continued its brief career with Ryan. The improved performance gleaned from the design changes would serve the Cloudster well when, after the demise of the airline, it found itself being used for an impromptu beer supply mission. Not long into the era of Prohibition, many towns across the US-Mexican border were making a tidy profit out of those who crossed the border for a drink. But just before Christmas of 1926, heavy rains had washed out the main roads that connected to the town of Tijuana with its supplier of beer. Not wishing to disappoint their eager patrons, and not wishing to miss out on a serious amount of Christmas cash, the various bars of the town banded together and chartered a series of aircraft. Among the aircraft selected was the Cloudster. During the height of its aerial beer run, which saw the Cloudster crammed to the brim with kegs, it was then diverted for a chartered passenger flight, as the floods had washed out many main roads. Unfortunately, the pilot, who was flying it from Tijuana to Ensenada, had to attempt a night landing on the beach, and he rather miscalculated it and put the wheels down in the sea. Thankfully, it was right near the beach, so the water was shallow, but it did produce enough drag that the aircraft nosed over. Thankfully, both pilot and passenger made it out of the aircraft unharmed, but the tide was rising, and that night it completely consumed the poor, stranded Cloudster, and its story came to a soggy and damp end. Now, with the anticlimactic saga of the Cloudster concluded, we'll return back to 1921.
Not long after the Davis-Douglas Company was reformed into the Douglas Company, it had received a contract for what would become the first military aircraft to bear the Douglas name, and it marked the beginning of a long and fruitful working relationship between Douglas and the US Navy. Douglas had heeded the advice of his old friend and mentor, Hunsaker, who was now a commander in the US Navy, and when said Navy had sought out designs for its first dedicated torpedo bomber, Douglas got to work and drew up a proposal. What would become known as the DT-1 was quite similar to the Cloudster, sharing its thick struts and somewhat slab-sided appearance, but there were differences. For one thing, the Cloudster had an all-wood structure, whereas the DT-1 would be made of mixed construction. The fuselage was built in 3 sections. The forward and centre sections had a structure of welded steel tube that was clad in aluminium coverings, and the rear section was a steel structure covered in doped fabric. The horizontal tail surfaces were also made from welded steel tube with fabric coverings, but the structure on the vertical fin, as well as the wings, was made of wood. As originally proposed, the aircraft was a single-seat design. It could be equipped with either a wheeled undercarriage or floats. It had folding wings, and it would carry a 1,835-pound torpedo in a recess beneath the fuselage. After completing the plans for the aircraft, Douglas went to Washington to submit his proposal, and on the 14th of April 1921, his first military contract was awarded, ordering the production and testing of 3 experimental aircraft to be designated as the DT-1. The first DT-1 was completed by October of 1921, and it was powered by a 400-horsepower Liberty engine. At the time of its completion, the DT-1 was fitted with twin floats, but for its first flight this was changed out to a wheeled undercarriage. Eric Springer took it up for its first flight in early November, and on the 10th of that month, he then flew it onto the Naval Air Station in San Diego for its acceptance trials. These trials were completed without incident, with both wheels and floats, by the end of December of 1921. Though the DT-1 was remarkably successful for a first attempt, in that pretty much nothing went wrong during its entire trialling period, the Navy was not fully satisfied. Or rather, the naval pilots weren't fully satisfied. It was felt that a torpedo bomber would need a crew of 2, or perhaps even 3, to be practicable. Currently, the pilot was being forced to manage the handling of the aircraft, the navigation of the aircraft, and the operation of the torpedo in combat conditions. Additionally, this meant that the torpedo bomber in its current configuration was defenseless, and a second position for at least a gunner was highly recommended. Based on this feedback, the Navy instructed Douglas to modify the second and third prototypes accordingly. To accommodate a position for the observer/navigator/gunner, the pilot's cockpit was moved forward to a position immediately beneath the upper wing. The new second position was then placed just behind the trailing edge of the wing, and it came with a single 30 caliber machine gun on a flexible mount. These changes were submitted and subsequently approved, and the second and third DT-1s were modified and completed in early 1922, being redesignated as the Douglas DT-2. It was fortunate for Douglas that 3 of these aircraft had been specified by the Navy, because had they only built just the one, 1922 would not have been a good year. On the 8th of March, the first DT-1 struck the water and nosed over during a high-speed run over San Diego Bay, which wrote it off, and later on in that year, with less than 7 hours of recorded flight testing aboard, the first of the DT-2s was written off in a landing accident on the 19th of July at Anayas Anacostia. Fortunately for Douglas, a third time was in fact the charm, and the second DT-2, which made its maiden flight on April the 18th, survived its trial period without incident. This third prototype differed from the first 2 when it came to the power plant. The radiators, which were mounted externally on the fuselage, were replaced by nose-mounted radiators that were installed within the cowling. Additionally, a slightly more powerful version of the Liberty engine was installed, putting out 450 horsepower instead of 400. This was done to offset the additional weight of modifying the airframe to accommodate the second crew member. Following the initial flights, the only other major modification made during the testing period was to move the oil cooling radiator back outside the engine cowling, as it was found to easily overheat. And with these changes made, the DT2 completed its Board of Inspection and Survey trials at Anacostia by the end of January of 1923. Even before these trials were completed, the Navy had liked what they'd seen. In competitive trials against aircraft submitted by Curtiss, Stout, Fokker and Blackburn, the DT2 was superior in almost all metrics. It was easier to handle, it was easier to maintain, and its steel structure was the strongest by a considerable margin, and they decided to order the DT2 into production, placing 2 initial contracts for 24 aircraft in total. For Douglas, this being his company's first military design, this was a huge achievement. But they were now faced with a bit of a problem. They had just received an order for a relatively large number of aircraft, 24, and they only had a rented loft in which to build them. To accommodate the new demand, the Douglas company had to very quickly move said production out of said rented loft, and it ended up leasing a new facility on Wilshire Boulevard, an old movie studio which happened to come with a conveniently large field next to it, which was perfect for testing aircraft. Work at the new facility quickly got underway, with 5 DT2s being delivered by the end of 1922, and the initial orders had been completed by the following year. By mid-1923, the DT2 was already earning a good reputation for itself within the Navy, and thus for Douglas itself, and the company received a repeat order for 20 more DT2s at some point in the spring. Additionally, the Lowe Willard Fowler Engineering Company produced 20 more DT2s under license. During this time, the only major change to the design had been the addition of a newer and larger balanced rudder. This was based on the feedback that pilots required a little bit more low-speed control to improve the accuracy of torpedo attack runs. These changes were made to aircraft already on the production line, and later on they were retroactively applied to DT2s that were already in service. In service with the US Navy, the DT2s were flown primarily as float planes from seaplane tenders and shore bases, being operated by 5 different torpedo squadrons: VT-1, VT-2, VT-5A, VT-19, and VT-20. Some DT-2s were also operated from the first US aircraft carrier, USS Langley, to develop free and catapult-assisted takeoff techniques. In May of 1924, DT-2s carried out the first successful launch of an aircraft carrying a torpedo from a carrier, albeit a dummy one for the sake of safety, and in April of 1925, DT-2s were used to test the feasibility of flush-mounted deck catapults. An improved version of the aircraft, known as the DT-3, was proposed by Douglas in 1923, but it was not produced. However, 5 other versions of the aircraft were produced by modifying existing DT-2 airframes for various purposes. The DT-4 was developed by the Naval Aircraft Factory, which re-engined 4 of its aircraft with 650 horsepower Wright T2 engines. These were intended to be used primarily as light bombers, rather than torpedo bombers, but they ended up seeing limited service. One of them did earn a bit of fame when it was entered in a load-carrying aircraft race, where it claimed the fastest lap with an average speed of 115 miles an hour, or 185 kilometers an hour, but aside from this, the DT-4s led a pretty boring life. 2 of the DT-4s were then modified as the DT-5, with the only modification being a geared version of the Wright engine being installed, and the DT-6 was a single aircraft, the last DT-2 to be built in fact, and this was equipped with a 450 horsepower Wright P1, which was a 9-cylinder air-cooled radial. The P1 was a direct forerunner to the highly successful Wright Cyclone, and much of its early testing was done with the DT-6. And finally, there was the SDW-1, which was a long-range floatplane scout developed from the DT-2 airframe. These were produced by the Dayton Wright Company, who took 3 DT-2s, removed the torpedo rack, and deepened the hull to allow the installation of additional fuel tanks. Though the DT-2 had a comparatively short service life with the US Navy, with the type being retired by late 1928, it had done wonders for Douglas's early reputation. Not only had naval aviators adored it for its forgiving handling, but it had become Douglas's first export model when they sold it to Norway. This in turn had a profound effect on the fortunes of the Douglas Company. In 1922, its first year of operations, the company had produced just 6 aircraft for a total value of $130,000. In 1926, just 4 years later, the company's production had risen to 120 aircraft, a 20-fold increase, for a total value of $1.66 million, which was a growth of 1,270%. But this astonishing feat was not the DT-2's biggest legacy, for it was used as the foundation to develop one of the most famous aircraft from the mid-1920s, and one of Douglas's most famous aircraft in general, and that was the Douglas World Cruiser. The World Cruiser could easily claim to be one of the 2 most symbolically important aircraft that Douglas would ever produce, the other being the DC-3. It was also incredibly important to Douglas in general. The World Cruiser became the first aircraft to circumnavigate the world, a feat that became echoed in the company motto and its branding. It would earn the company a huge amount of national prestige, as well as putting Douglas firmly on the international stage, and it would establish a strong relationship between Douglas and the US Army in the same way that the DT-2 did for relations between Douglas and the US Navy. During the spring of 1923, the US Army had begun to show considerable interest in the idea of a flight around the world by a formation of military aircraft. Specifically, they wanted theirs to be the first to do it. Despite the Wright brothers having claimed the world's first heavier-than-air powered flight over 20 years ago, aviation in the United States had lagged behind the rest of the world. Its industry had essentially played the world's biggest game of catch-up during World War I, and in the immediate post-war slump it almost collapsed completely. But by 1923, things were beginning to change. Now, enough people were in positions of senior office that aircraft development was at least being treated as a serious military and commercial matter, and a group of army officers were given the task of planning this global venture. This involved plotting out the route of the journey, organising the vast amount of required logistics for the various stopping points, which involved putting fuel supply dumps in, spare parts, engines, etc., and of course, the officers had to find an aircraft suitable for the task. Very quickly, they realised that none of the aircraft already operated by the air service were actually suitable for this attempt, and they widened their search to look at the entire US aircraft industry. One of the requirements was that the selected aircraft had to be easily swapped between a wheeled undercarriage and floats. Because of this, the War Department organised its team to collect data on various civil aircraft to see which models were most suitable for rapid conversions, and one of the aircraft selected was the Davis Douglas Cloudster, which was still a couple of years away from its fate of crashing into the sea. But when approached by the Army officers, Douglas declined to provide details for a modified Cloudster, and instead drew up specifications for a heavily modified version of the DT-2, designating it as the DWC, which stood for Douglas World Cruiser. Though designed as a long-distance record setter, Douglas felt that the Cloudster design wasn't up to the task, and that the superior steel structure of the DT-2 would be far more suitable to a journey as ambitious as a full circumnavigation. Additionally, the DT-2 had already been designed with an interchangeable undercarriage in mind, which was one less problem for the design team to worry about. And Douglas claimed that because of this, they could have a modified aircraft delivered to the Army within 45 days of receiving a contract. Having reviewed other submissions, the Army felt that the Douglas proposal held the most promise, and it sent Lieutenant Eric Nelson to work with the company as their representative, whilst Douglas formalised the required modifications for the new DWC. Structurally, there was no need to actually modify the aircraft, but changes were soon required owing to considerations about its fuel load. On the DT-2, a large part of the useful load was taken up by the Torpedo and other military equipment. But of course on the World Cruiser, to give it the necessary range for long-distance overseas legs of its journey, with reserves to spare for obvious safety reasons, the fuel load had to be dramatically increased, and this necessitated a complete redesign of the fuel system.
The DT-2 in its original form carried 115 gallons, or 435 litres of fuel. The World Cruiser, on the other hand, was planned to carry 644 gallons, or just under 2,500 litres. This would be achieved by filling every conceivable empty space, not required for equipment or people, with said fuel. There was a tank in the centre section of the upper wing, a tank in each wing root of the lower wing, a tank behind the engine's firewall, a tank beneath the pilot's seat, and a tank beneath the observer's seat. This complex system of tanks, and their necessary fuel lines, was designed by a relative newcomer to the Douglas Company, one Jack Northrop. In fact, the World Cruiser was the first design in which he played a major role, and it kick-started a long and passionate career in aeronautical engineering, one which will be discussed in its own video in the future. Aside from the modified fuel system, which in the wrong circumstances could turn the DWC into the world's largest flying fuel-air bomb at the time, other changes on the aircraft included additional radiators, for use in tropical climates, modified vertical tail services for improved stability in poor weather, the addition of support struts beneath the tailplane, the cutting out of a part of the centre section of the upper wing to improve visibility and nighttime navigation, and the observer's position was moved further forward to improve communication with the pilot. As much of the aircraft was still structurally similar to the DT-2, it didn't take long to build the prototype World Cruiser once approval had been given by the War Department. It was successfully flown and tested in the autumn of 1923, and on November the 27th, Douglas received a contract to produce 4 World Cruisers. By the 11th of March 1924, all 4 had been delivered, and they were each named after a major American city. There was the Seattle, the Chicago, the Boston, and the New Orleans. Once supplies and spare parts had been placed at various locations along the planned route, which included no less than 15 spare Liberty engines and 14 sets of floats, the official start date was set for April 2nd, 1924, with the aircraft taking off from Sand Point at Lake Washington in Seattle. Poor weather and a broken propeller did delay things by a couple of days, but on the 4th of April, all 4 of the World Cruisers departed Seattle for the first leg on their journey, which was Prince Rupert in Canada. From there, they flew on to Alaska, stopping at Sitka, Cordova, and Chinook, which I hopefully got the pronunciation correct, where the lead aircraft, which was Seattle, was unfortunately forced to stay behind for engine maintenance. Its poor luck then continued a few days later, when it got caught in fog trying to catch up with the other 3, and it crashed into the side of a mountain. Its 2 crew members, Major L. Martin and Staff Sergeant A. Harvey, survived the accident, and they then had to endure a freezing 10-day hike through blizzard conditions before finally reaching civilization at Port Moller. Meanwhile, Chicago, Boston, and New Orleans carried on. They arrived at Yokohama on the 24th of May, and then they proceeded via Korea, the Chinese coast, Hong Kong, French Indochina, Thailand, and then Burma to reach Calcutta. There, they replaced their floats with wheels and continued westwards across India, the Middle East, southern and then Central Europe, arriving in Paris just before Bastille Day. After a quick hop across the Channel to London, and then northwards, the World Cruisers were once again fitted with floats for the Atlantic crossing. Only 2 would make the crossing successfully. The Boston, which was flown by Lieutenant Wade and Sergeant Ogden, suffered an oil pump failure, and it had to land in the middle of the Atlantic. Fortunately, after drifting at sea for some hours, they were spotted and rescued by the USS Richmond. Unfortunately, whilst being towed, and just a mile away from safe harbour at the Faroe Islands, the Boston would be capsized in rough seas. This was not the end of Wade and Ogden's journey though. The prototype World Cruiser, which had been held in reserve, was hurriedly prepared to meet them in Nova Scotia. Though they could no longer claim the distinction of making a full circumnavigation in the one aircraft, they could at least carry on the journey with the others. In the meantime, Chicago and New Orleans had completed the crossing of the Atlantic successfully, going via Iceland and then Greenland, and they met up with the newly christened Boston 2. They then travelled across Canada and the United States to much fanfare, and arrived in Seattle to a hero's welcome on the 28th of September. With their wheels firmly on the ground, the Chicago and New Orleans had just completed the world's first circumnavigation by aircraft. From the official start to the official endpoint, they had flown 27,552 miles, which is 44,342 kilometers. Flight time totaled 371 hours and 7 minutes, and the journey was completed across a period of 175 days. The long total journey time was because of a couple of things. There were sometimes stops for weeks, depending on maintenance, supply, and weather conditions, and often there were a lot of press and promotional related events going on along the way as well, which of course added to the total journey time. Owing to their prestigious achievement, it was decided that both the Chicago and the New Orleans were to be preserved, and they can still be found today. Additionally, the Army, who were understandably impressed by the world cruiser, ordered 6 more for use as observation aircraft, and these were designated rather imaginatively as the Douglas Observation Seaplane. These aircraft retained the interchangeable undercarriage of the world cruiser, but had the fuel capacity significantly reduced, as the US was still a few decades away from its pathological desire to send observation aircraft to every corner of the globe, and a pair of 30 caliber machine guns were mounted in the rear cockpit for defense. Redesignated as the O5 in May 1924, they were operated by the 2nd Observation Squadron of the Philippine Aviation Department for a number of years. The combined success of the DT-2 with the US Navy, and the world cruiser with the Army Air Service, solidified the reputation of the Douglas Company with the US military in general, and its work for these establishments quickly grew in scope. Though Douglas himself still aspired towards producing a reliable and hopefully lucrative commercial transport, the value of producing military aircraft could not be ignored, and indeed it was truly realized with the company's next major achievement, the winning of the 1924 Observation Aircraft Competition, which had been held by the Army. This competition was intended to find an aircraft to replace the aging DH-4B, which was an American version of the Airco DH-4. This had the potential to provide the successful company with a steady supply of orders, as observation aircraft tended to be more long-lived and less frequently replaced than combat aircraft, and thus it promised to be a reliable source of income. Earlier in the year, Douglas had been awarded a contract to produce 2 prototype aircraft, both known as the XO2, to submit into this competition. These were identical except for the power plant, both of which were liquid-cooled V-engines. Due to a large number of surplus Liberty engines, of which an excessive number had been ordered during the First World War, but were mostly not delivered until hostilities were all but over, the War Department had insisted on aircraft being designed and tested with this engine first. The second XO2 was to then be powered by a competing V-engine, which was the 510 horsepower Packard 1A-1500. The Liberty-powered XO2 was first tested by Eric Springer in the autumn of 1924, after which it was delivered for competitive trials at McCook Field. During said trials, it proved to be significantly faster than the DH-4, the aircraft it was designed to replace, and in general, it performed much better than the other competing aircraft submitted. This resulted in a unanimous recommendation by the evaluation board to adopt the aircraft for service, and Douglas subsequently received its single largest order to date, requiring them to rather quickly produce 75 aircraft known as the Douglas O2. This would be the start of a long line of observation aircraft built by the company. Between 1924 and 1936, the Douglas Company, and then the Douglas Aircraft Company, a switch which we will get to later, produced some 879 of these aircraft across a staggering 50 different variants. The Douglas observation planes would be among some of the most important types of US military aircraft built in the interwar period, and they were by far and away the company's biggest financial success until the arrival of the DC-3. Now, for reasons that mostly involve keeping this video to a reasonable length, I won't cover all of the O2 variants in detail, but we will take a look at some of the honourable mentions. Firstly, we have the original, the O2. Though an order for 75 was placed, only 45 would be delivered to this original specification. They were generally identical to the XO2, but they had a simplified engine installation with a large, modified tunnel-type radiator, which was mounted further back behind the propeller shaft. Additionally, the engine now produced more power, 435 horsepower versus 410, and in its original configuration, the O2 was good for a maximum speed of 128.5 miles an hour at sea level, or roughly 207 kilometers an hour. In terms of armament, the O2 came with a fixed forward-firing 30 caliber machine gun, a second mounted in the rear on a flexible mount for defense, and it could carry up to 4 100-pound bombs on underwing racks. Its non-standard equipment could also include the installation of additional machine guns, one 30 caliber over each lower wing, smoke dispensers, and in some cases, photographic equipment for reconnaissance and surveys. Within weeks of the first O2s arriving, other variants began to follow suit. The O2A was identical to the O2, but also came with night-flying equipment, and the O2B was a command aircraft fitted with dual controls, one of which was used for some time by the Chief of the Army Air Service. The O2BS was a one-off design that was ordered by pilot James McKee. His intention was to make an attempt at the first single-pilot, single-aircraft trans-Canadian flight. For this, all the military equipment of the standard O2 was removed, and the landing gear was swapped out for amphibious floats to take advantage of the countless lakes and rivers dotting the Canadian wilderness. The attempted flight was a success. Between the 11th of September and the 19th in 1926, and with the help of Canadian authorities, which provided all necessary support and logistics, and assisted by squadron leader Earl Godfrey as liaison officer and navigator, McKee flew the 3,000 miles, or 4,800 kilometers, between Montreal and Vancouver in just under 36 hours, at an average speed of 85 miles an hour, or 137 kilometers an hour. Following the O2C, of which 46 were built, which came with a new flat radiator, the next major variant was the O2H. This version could almost be considered a completely new design, but the O2 designation was nonetheless retained. It had a revised fuselage structure, new tail surfaces, a streamlined undercarriage, and it had new staggered wings of unequal span. Unlike previous versions, these wings did not house any fuel tanks, and all of the fuel was now stored in a single tank between the cockpit and the engine. A total of 140 O2Hs would be built, and along with the aforementioned changes, they were also notable for being the first to make the switch to all-metal propellers. After this came the O2K, which was an improved version of the O2H, with 37 being built for the Air Corps and 20 for the National Guard. But the K was most notable for its role as a training aircraft. 40 would eventually be modified with dual controls and redesignated as the BT-1, or Basic Trainer 1, not to be confused with the short-lived Northrop BT-1 dive bomber. Thankfully, the two were quite easy to distinguish. One was a biplane, one was a monoplane. One handled like a dream, according to the pilots. The other tried to kill you if you tried to roll the aircraft over. That being said, the Northrop BT-1 would redeem itself when it was eventually redesigned into the Douglas SBD Dauntless, but that is a topic for later discussion. Eventually, other Douglas observation aircraft would be converted into trainers as well, or have their designs modified to be built as dedicated trainers from the outset, with the list including the BT-1, the BT-2, the BT-2A, the BT-2B, the BT-2BI, the BT-2BG, the BT-2BR, the BT-2C, the BT-2CI, and the BT-2CR. These designations admittedly covered general flight trainers, instrument trainers, and radio-controlled aerial targets, but in general they were variations on a theme. All of them were very successful in their own right, and all of them led active but fairly unglamorous duties in either providing training opportunities or quite literally training the future pilots of the American Air Forces. Another offshoot developed from the O2 observation aircraft was a series of mail planes that began with the DAM-1. In 1925, the US Postal Service negotiated with Douglas to develop a replacement for their fleet of modified DH-4s. At a glance, this new aircraft looked almost identical to the O2, but there were actually some major changes. All of the military equipment was obviously removed, though the concept of an armed and aggressive postal service is as hilarious as it is terrifying. The observer's cockpit was deleted, and the pilot's cockpit was moved further back. This allowed the installation of a fireproof compartment that could store approximately 1,000 pounds, or 450 kilos, of mail. The first of these modified mail planes flew in early July of 1925, after which it was leased to the post office for a year so that they could evaluate its performance across the seasons and in various weather conditions. It was operated primarily on the Illinois-Nevada section of the transcontinental mail route. Equipped with 150,000 candle power lights and parachute flares for night operations, the aircraft proved to be faster, more capable, and more reliable than the old DH-4s. They also handled poor weather better, and they were in general considered easier to fly. The type was then ordered in quantity by the post office as the M3. 10 of these were produced, and they were soon followed by an order for 40 M4s, which had an increased wingspan of 44 feet 6 inches, compared to the 39 feet 8 inches on the original, which for those of us on the metric system is a difference of about 1.5 meters. Unfortunately, the M4s would barely get any service before the majority of the air routes were privatized, and many Douglas mail planes found themselves up for auction. Some found themselves in the hands of the Army Air Corps, and some were purchased by the National Air Transport Company. Others served for a time as combined airmail and passenger transports, and the M2 variant was specifically ordered by Western Air Express for this very purpose. Their commercial use was short-lived though, as the introduction and then the mandating of multi-engine aircraft for transport duties soon relegated most of them to the scrap heap by the early 1930s. Getting back to the observation planes, a change in the wind came with the O-25C. It was the last of the Douglas observation aircraft that was to be powered by a liquid-cooled engine, and it also reflected a general shift in the aviation industry of the United States. Across the board, the air-cooled radial engine was rapidly becoming the dominant power plant of choice. The most notable of the radial-powered O-planes were the various derivatives of the Douglas O-38. With the exception of a few individual examples, these were all powered by the 9-cylinder Pratt & Whitney R1690 Hornet, and somewhere between 155 and 168 were built. Sources do conflict on the exact number. Of these, the O-38F was to be the last War Department designated version that Douglas built. Produced as an unarmed transport with an enclosed canopy, it was delivered for use within the National Guard. The National Guard, in fact, is where the O-planes earned their best reputation. By 1926, at least 15 National Guard observation squadrons were already operating the Douglas O-2 in some capacity, and in later years they received various later models, depending on their operational requirements. Some of these aircraft would come straight from Douglas production lines as a direct order for the National Guard, while others were hand-me-downs from the Air Corps as they upgraded to more modern monoplanes, some of which would still be built by Douglas. Despite the rapid march of technological progress during this time, they were not phased out of the National Guard inventory completely until 1942. This was because they were very easy to fly, a quality that is echoed by every pilot who has essentially touched one of these aircraft, and more importantly for the National Guard, they were very easy to maintain. The National Guard's air units had nowhere near the sort of logistical support that was found within the Army Air Corps, and having an aircraft that was easy to maintain was far more important than having one that had all of the latest technology. These observation aircraft, operated for many years by both the Army and the National Guard, formed the bulk of Douglas's production in the mid to late 1920s. So much so that the company's other aircraft developed during this time period are almost completely forgotten. In fact, from the standpoint of personal ambition, the success of the O-2 and its derivatives actually prevented Douglas from achieving his original goal of producing a successful transport, at least in the short to medium term. During this time, the company's limited engineering staff was kept perpetually busy with military design work, both in drawing up new designs and modifying existing ones to the needs of the Army, the Navy, and the National Guard. This understandably limited the amount of man-hours available to work on civil designs, and this was further compounded by the fact that Donald Douglas, like several others of his peers in the early 1920s, had grossly underestimated how rapidly competitive the private and commercial markets were becoming. His first attempt to break into the private market came with the Douglas commuter. Like several other designers, Douglas believed that a large number of ex-service pilots from the First World War would want to continue flying, and he predicted a booming market for light and inexpensive private aircraft. In response to this, he designed a small two-seat aircraft that could either be powered by a 35-horsepower three-cylinder Anzani, or a 60-horsepower Wright Gale. This aircraft, Douglas's first monoplane design, had high-mounted externally braced wings, which could be manually folded along the fuselage, so that the whole thing was slim enough to fit into a common garage. Built primarily of wood, with fabric coverings, with the exception of the engine cowling, the commuter was meant to be easy to assemble, and able to be produced from a simple workshop. The prototype first flew in January of 1926, but even though test pilot Eric Springer said that it handled well, it would remain the only example of the commuter to be built. Competition was exceedingly fierce in this new market, with countless light aircraft being designed and tested in the early to mid-1920s, and Douglas couldn't justify neglecting his military obligations to further develop the commuter into something more competitive. A similar fate befell the Douglas DA-1, also known as the Douglas Ambassador. Like with the commuter, Donald Douglas went with a monoplane configuration, except this time he went with a parasol wing. Design work began in 1926, but things progressed at a glacial pace because Douglas had to prioritize the production of all of their military aircraft. In fact, most of the work on the DA-1 was done in the off-hours by Douglas himself and a small team. Unlike the commuter, which was still going through its flight trials at this point, the DA-1 was conceived as a vastly different machine, with an emphasis placed on sturdy construction and reliability, rather than on low manufacturing and operating costs. As such, the DA-1 was built of mixed construction. The fuselage was made from a light steel framework and clad in a mix of plywood and fabric. The wings were built up from spruce and had a plywood covering, except for the control surfaces, which were still fabric covered, and it was powered by a much more powerful engine, a 220 horsepower 9-cylinder Wright Whirlwind. Though it was superior in general to the Douglas commuter, the DA-1 would also only exist as a single aircraft. Additionally, it almost deprived the company of its founder. After attending the El Paso air races in late 1928, Eric Springer and Donald Douglas went to fly the DA-1 back to their factory in Santa Monica, but the DA-1 crashed on takeoff. Fortunately, both men walked away unharmed, but the aircraft was written off due to extensive damage to the undercarriage and lower section of the fuselage, and no attempt was made to build a replacement, as Douglas wanted to focus on producing more aircraft for the Army Air Corps. These early failures at civil aircraft didn't deter Donald Douglas, but they certainly helped him to further appreciate the value of successful military contracts. This is further highlighted by the fact that his only successful transport design from this period was one that had been produced for the Army, and that was the Douglas C-1. Produced about a year before the failed commuter and the DA-1, the C-1 was designed to meet a War Department requirement for a large single-engine transport. These were similar in construction to the Douglas World Cruiser and the O-2 biplanes. The fuselage was built from welded steel tubing, with the forward section clad in aluminium and the rear in fabric, while the wooden wings now featured a metal leading edge. The C-1 was designed to accommodate a pilot and a co-pilot, which were sat abreast in an open cockpit, along with up to 8 passengers in an enclosed cabin immediately behind them. Alternatively, the passenger seats could be quickly removed, and the C-1 could be used as a cargo transport, with a maximum load of up to 2,500 pounds, or about 1.1 tons. The first C-1 made its maiden flight from Santa Monica on the 2nd of May 1925, completing its service trials by the end of the month. The initial order for the C-1 was for 9 aircraft, and all of these were delivered by the end of the first year. One of these was used as an experimental testbed for a time, being equipped with geared Liberty V16-55 engines, and being redesignated temporarily as the C-1A.
For several months, it was tested with various undercarriages and engine cowlings, including the installation of skis for winter operations, before being returned to standard C1 spec at some point in late 1926. Plans were drawn up for an improved version, known as the C1B, which was never built, but the War Department did place a follow-up order for 7 examples of the C1C. This version had an increased wingspan, new exhaust manifolds, and a slightly modified undercarriage. It was also now designed to be used as an ad hoc medical transport as well, as internally there was now provision for the carrying of up to 4 stretchers. In service, the C1s and the C1Cs were attached individually or in small groups to major army airfields, rather than being assigned to specialized transport squadrons, as for their type they were still quite small. 10 additional C1Cs were ordered and delivered in 1927, after which they led a successful but ultimately mundane life, with the only exception being a C1 that was used for early aerial refueling tests in 1929. By the time the last C1 was completed in 1927, the Douglas Company was almost unrecognizable from the small enterprise that had started just 5 years earlier. In 1922, Donald Douglas had scrambled to organize a $15,000 loan to get things up and running, and yet in a few short years, his company boasted almost $2 million in net sales for the fiscal year of 1927, and since its inception, it had now delivered just under 300 aircraft, which for a company operating from a disused film studio wasn't bad work at all.
Along with producing the aforementioned aircraft, the Douglas team had also cut their teeth with twin-engine designs, assisting with, or outright taking over, the work on the twin-engine T-2D1 torpedo bomber. Though little known today, this aircraft design was of significant importance. The T-2D1 was a groundbreaking aircraft in several ways. It was the first twin-engine design from Douglas, and the first twin-engine plane that was built to operate from aircraft carriers. Its development history was quite unusual, tracing back to an original naval aircraft factory design for a versatile single-engine plane. This design evolved then into a 3-seat land-based or seaplane torpedo bomber, which was powered by a 525 horsepower Wright T2 liquid-cooled engine. The Curtiss Aeroplane and Motor Company initially built 6 of these aircraft as the CS-1, and then the Glenn Martin Company followed with a production run of 35. While Martin refined the Naval Aircraft Factory's original design into a series of torpedo bombers, the factory's engineering team focused on improving the performance of the base concept. This led to the development of several variations: the single-engine TB-1, which was built by Boeing, and 2 twin-engine prototypes, the XTN-1 and the XT-2D-1, built by the Naval Aircraft Factory and Douglas respectively. At the time, the Bureau of Aeronautics prioritized multi-purpose aircraft to maximize the limited space aboard aircraft carriers. These planes had to perform multiple roles, including level bombing, torpedo bombing, and scouting, and be adaptable for both land and sea-based operations. However, these varied requirements created significant performance challenges, which prompted the factory to explore performance-enhancing options. For the Boeing TB-1, this was achieved through brute force by using a powerful 770 horsepower Pickard 1A 2500 liquid-cooled engine. Meanwhile, the Naval Aircraft Factory also studied the potential of a twin-engine design. Twin engines promised not only better performance but also increased reliability and safety for long overwater missions. By 1925, new air-cooled radial engines from Pratt & Whitney and Wright were becoming available. These delivered over 500 horsepower, but were lighter than contemporary liquid-cooled models. Seizing this opportunity, the Bureau tasked the Naval Aircraft Factory with building the experimental XTN-1, and it awarded Douglas a contract for 3 prototypes that were known as the XT-2D-1. The Naval Aircraft Factory's prototype would serve as a benchmark for Douglas, which would be trusted to handle any further production orders. This trust was quite extraordinary at the time, as the Navy directly approached Douglas rather than seeking competitive bids, which was a testament to the company's growing reputation. The first XT-2D-1 was completed in January 1927. It featured two 500 horsepower Wright P2 radial engines, which were mounted on the lower wing and driving two-blade propellers. Its design bore a strong resemblance to the single-engine Martin T3M1, particularly in the tail and in the rear fuselage. However, the Douglas design also included significant changes, such as tandem open cockpits for the pilots, a relocated rear gunner/wireless operator cockpit, and a fourth cockpit in the nose with a flexible machine gun mount and bomb aiming equipment. The aircraft made its maiden flight on January 27, 1927, and was soon sent to NAS Anacostia for service trials. However, reliability issues with its Wright engines delayed its readiness for carrier's qualification. Eventually, these engines were replaced by more reliable Wright R1750s. These were yet unnamed, but would soon be christened as the venerable Wright Cyclone. Operational trials began in May 1927 with Torpedo Squadron 2. The Navy then placed a limited order for 9 T2D1s, incorporating changes such as a redesigned engine nacelle, a shorter fuselage for better balance, and improvements to the cockpit and control layout. A taller, balanced rudder was also added to enhance stability at slow speeds, particularly for carrier landing. In service, air crews appreciated the T2D1 for its good speed, as it was 15% faster than the single-engine Martin T3M, and it provided excellent visibility for the pilots. However, its size and weight did limit its suitability for carrier operations. Engine reliability was still a significant issue, and nobody wanted to attempt a single-engine landing with a twin-engine aircraft aboard a carrier in anything other than completely ideal conditions. Ultimately, the Navy decided to standardize on the single-engine Martin T4M1 for carrier use, and they reassigned the Douglas T2D1 to shore-based operations. In Hawaii, the T2D1s conducted topographic surveys and operated as seaplanes for maritime reconnaissance. Crews valued the aircraft for its ability to handle heavy loads with ease and to climb quickly. Based on this success, the Navy ordered 18 modified aircraft in 1930. These were designated as P2D1s, reflecting their focus on maritime reconnaissance. The new planes featured twin tail fins for improved single-engine control, increased fuel capacity, and uprated engines. The first P2D1s were delivered in early 1931, and they would enter operation in the Panama Canal Zone until their retirement in 1937. By then, the era of the T2D1 and its successor had well and truly come to an end, but these aircraft had paved the way for future twin-engine designs that would come out of the Douglas factory. In parallel with the work on these aircraft, Douglas had also assisted in the production of the Naval Aircraft Factory PN Flying Boat. Based on a British Felixstowe F5L, these aircraft were barely modified by the Douglas team when the factory was given a production contract. However, it did provide the engineering staff with vital experience on the tooling and construction for flying boats, something that would come in handy sooner than many of them had realized. Now by this point, Douglas now employed several designers who would go on to achieve fame within the company, or with others in the future. Among those on Douglas's payroll was Arthur Raymond, whose name would be immortalized a decade later when he led the team that would design the Douglas DC-3 airliner. Another designer was the young John Northrop, who first worked on the World Cruiser, and who would bounce between Douglas and Lockheed for the next few years before forming the Northrop Corporation, which would begin as a Douglas subsidiary. Yet another Douglas employee was one James Dutch Kindleberger. He would go on to work on the DC-1 and DC-2 airliners, but he is most remembered for his work at North American Aviation. There, he led the team that designed the P-51 Mustang, transforming the company's fortunes overnight and kickstarting a long and highly successful career. But all of these achievements happened in the next era of Douglas aircraft, for the time of the Douglas Company was drawing to an end. By mid-1927, production was increasing at such a pace that the production facilities of Douglas's Wilshire plant were struggling to keep up. Additionally, space was becoming a big problem. Not only were aircraft being crammed here, there, and, well, everywhere, often being parked outside under canvas coverings, but the adjacent grass field wasn't big enough to test newer and more powerful aircraft. This meant that new aircraft were having to be towed from the plant by night to Clover Field, which was about 2 miles away. For the occasional plane, this wouldn't have been too much of a problem, but as the production numbers rapidly grew, this nocturnal practice soon became unsustainable. Douglas's lease of the Wilshire facility was due to expire in 1929, and with no room to expand, it was clear that the company had to find a new home.
In its short but successful time of operations, Douglas had become quite the financial asset for the city of Santa Monica, and not wishing to lose said asset, the city made Douglas an offer. They were prepared to cooperate with Douglas to expand and update the facilities at Clover Field if Douglas were to build their new factory on the adjacent land. Douglas was more than happy to agree with this proposal, but the required capital to build a new facility was currently beyond the scope of his business. Up until this point, the capital of the company was controlled by Douglas himself, Bill Henry, and Douglas's father, William, who had joined the company and brought in his financial knowledge from a career in banking. By the autumn of 1928, all but $40,000 of the net profits made since 1922 had been reinvested in the company, and as a result, the net worth had risen to $2.5 million. In cash, the company had about $1.4 million, which wasn't enough to build the facility that Douglas wanted, and after consulting with various financial firms, Douglas decided to completely restructure his company into something new so that he could acquire more finance to get things rolling. And so, on the 30th of November 1928, a new company, the Douglas Aircraft Company, was formed. This new company was supplied with additional finance, and it was divided into 1 million shares. 300,000 of these were directly issued to Douglas Aircraft, of which 200,000 were used to purchase the assets of the old company, and the remaining shares were sold to the public. Approximately 2/3 of the shares put money straight back into the company's cash account, to the tune of around 650,000, and the rest was used to set up Douglas's new production facility on the fringes of Clover Field. Completed in 1929, this new facility took up just under 8 acres of land, and combined with the upgraded facilities at Clover Field itself, it provided the Douglas Aircraft Company with a strong foundation for growth and development. The Douglas Company had only been in existence for about 7 years, but its successor would see almost 4 decades of operations before it too would restructure, merging with McDonnell to form McDonnell Douglas. The 4 decades leading up to that merger, though, were full of ups and downs, huge successes and some dismal failures. Good luck, bad luck, a Great Depression, a World War, and some singular design thinking that was often coupled with a surprisingly poor appreciation for the commercial market, which was a surprise considering Douglas's early aspirations.
After settling into their new home, the Douglas staff continued production of its observation biplanes for the US military, and production of the PD-1 flying boat also began. But more change was on the wind. Not only did the year see the Douglas Aircraft Company reformed and relocated, but it also saw its designs modernize into the emerging world of the all-metal monoplane. And this began with a little-known flying boat that would become known as the Douglas Dolphin.
The Dolphin was the combination of Douglas's passion for aircraft design and his love for the open sea, a love that had not diminished despite his now ever-busy career. Every weekend in the late 1920s, the Douglas family would go out on the Barbara Jean, a 40-foot schooner which he had named after his young daughter. They often visited Catalina Island, and Douglas entered the inter-island races each year, often winning, and he spent many spare hours teaching his 2 sons, Donald Jr. and William, the finer arts of seamanship and navigation. It was during these weekend holidays that he realized that there was probably a market for a luxury flying boat, as much as there was a market for private yachts, especially with the way that the economy was booming in the late 20s. And so, he dropped plans for a twin-engine flying boat that he called the Douglas Sinbad. The Sinbad represented several firsts for Douglas.
It was the company's first cantilever monoplane, it was Douglas's first attempt at a flying boat, and it was the first twin-engine aircraft design that was fully drawn up in-house. Like many of the new monoplane flying boats that were starting to emerge during this time, the Sinbad had high-mounted wings and even higher-mounted engines to keep both the sensitive equipment and the propellers clear of any water. These were a pair of 300 horsepower Wright whirlwinds that were enclosed in metal cowlings that sloped down into the wing structure, and it was with these engines that the Sinbad made its first flight in July of 1930. Unfortunately, by the time that the prototype Sinbad was completed, the economy of the late 1920s had gone from boom to bust, following the Wall Street crash. Luckily for Douglas, the company's strong ties with the Army and Navy now proved their worth, and the flying boat was saved from being a total loss. While the Sinbad was being tested, Douglas had already decided that the production model would be completed as an amphibian, to make it more appealing to both civil and military customers. It also received a new name, the Dolphin. These aircraft were fitted with retractable undercarriages comprising of a main gear attached to the hull, and a tailwheel replaced the skids on the tail. In flight or for water operations, the main gear was raised by shortening the oleo legs, thus lifting the wheels above the waterline, while the tailwheel pivoted upwards until it was close up to the bottom of the hull. While only 58 Dolphins were built between 1931 and 1934, this total included 17 different variants and models, as the Dolphins were either custom built for each civil customer, or produced in small batches for military and commercial buyers. Now, while the Douglas Cloudster and the M-planes had been used to carry passengers in the past, neither type had been originally conceived for that purpose. Because of this, the Dolphin, even though it was produced in small numbers, occupies a special slot in the company's history, as it was the first passenger-carrying commercial transport to be put into mainline production. Furthermore, during its many years of service with various bodies, such as the US Army Air Corps, the US Coast Guard, the US Marine Corps, the US Navy, and, surprisingly, the Royal Australian Air Force, the Dolphin earned a solid reputation for its reliability and good handling. In particular, the Dolphin was found to be incredibly useful when conducting air-sea rescue operations, and a couple of Dolphins that were used by the Army Air Corps in the late 1930s helped to pioneer new air-sea rescue techniques that would be used by both the Army, the Navy, and the Coast Guard. Of the various civil owners of the Dolphin, two of them stand out in particular. One Dolphin was built for Armand Esders, who is famous for his love of Bugattis and Rolls-Royces. When he walked into Douglas's office in 1933, Donald Douglas had no idea who he was, and he was surprised when the relatively young-looking man asked to buy one of his aircraft. Donald cautiously advised that they were quite expensive, but his reserve quickly gave way to shock as Esders produced a check for $57,000, asking if that would be enough to cover the cost of a Dolphin. Considering the Dolphin was advertised at just $45,000, it was more than enough. The reason for the extra-large check was quickly made apparent as Esders asked for a string of custom features for his aircraft, including fancier seats, a small bar, and various other glittery features. And Douglas assured him that he could have any special features he wanted within reason, so long as he could finance it. And so not long after this, Esders became one of the first people in the United States, at least, to get an executive aircraft precisely tailored to their needs. The other notable owner of a Dolphin was one William E. Boeing, the founder of the Boeing Company, and soon-to-be Douglas's biggest rival when it came to commercial aircraft. Ironically, the Dolphin that was bought and used by Boeing is the only one that happens to survive up until this day, and it's on display in Coast Guard livery at the National Museum of Naval Aviation in the United States. Though the onset of the Great Depression had been almost fatal for the Dolphin's success, the steady stream of military contracts kept the Douglas Aircraft Company alive and financially solvent during a time when many other companies were going bankrupt. It also allowed the company to continue its trend towards modernization. Douglas Aircraft had been gradually improving its series of observation biplanes, which had started with the O2. But as the 20s gave way to the 30s, it became clear that a monoplane design would be very soon required. Douglas knew that any military orders would probably be smaller in comparison to those for the O2, owing to constrained budgets in the wake of the Great Depression, but he wanted the company to remain as the Air Corps' primary supplier of observation planes, and that meant keeping up with the times. And so, with a mix of reserve and optimism, the company invested in and then submitted a design for a new monoplane observation aircraft, of which, to their relief, 2 prototypes were then ordered by the Army as the XO-31. At the same time as this, and in response to the twin-engined Fokker XO-27, Douglas also designed a twin-engine observation aircraft that would be known as the XO-35. This aircraft would never serve in its intended role, as the Army decided it was far more suited as a light bomber, and indeed what became known as the B-7 was only built in small numbers and would only see limited use. It would, however, be involved in a few interesting events, such as the airmail crisis, but that has already been covered in a dedicated video on the Douglas B-7 itself, so for further information on that particular aircraft, I recommend you watch that video later. The link will be up on the screen. Following a protracted development, where the XO-31 terrified pilots with a complete disregard for the concepts of aerial stability, things were eventually ironed out in the subsequent O-43A, which was ordered in 1933. This aircraft featured a sliding canopy that enclosed the tandem cockpits, it had an externally braced gull wing, and it was powered by a 675 Curtiss Conqueror. Though it was a monoplane, it was still something of a halfway house between the older designs of the 1920s and the more modern aircraft that would become synonymous with the 1930s. Because of this, only 23 of these would be produced before things moved on to the O-46. This improved the design by bracing the wings with parasol struts instead of fragile external wiring, and the engine was swapped out for a more reliable Pratt & Whitney twin Wasp radial. All in all, the Air Corps would order approximately 90 of the O-46s, which would be delivered between 1936 and 1937. A proposal for yet another improved variant, to be designated as the O-48, was considered, but this design was never built, and the O-46 would end up becoming the last major variant of observation aircraft that would be built by Douglas. This was because the needs of the Army were shifting, and a new aircraft type was being developed to reflect this, the liaison aircraft. These were small, unarmed planes designed to fill a number of auxiliary roles, such as artillery spotting, commander transport, message relay, air ambulance, and light cargo transport duties. None of these future aircraft, some of which would be built in huge numbers, would end up bearing the Douglas name. But this loss of business made little odds, as by the late 1930s, the Douglas Aircraft Company had established itself firmly in other, far more profitable markets. At the start of the decade, thanks to the O2 and its derivatives, and other designs such as the C-1, the O-43, and the XT-3D, there was no Great Depression as far as the Douglas Aircraft Company was concerned. As 1930 opened, the company had just under 100 aircraft on order, the majority of which were for the United States Army or Navy, and although sales did drop during the next 2 years, the financial position of the company in 1933 was still excellent, with cash and marketable securities of $1.5 million against just $200,000 in liabilities. This wealth of funds put the Douglas Aircraft Company in a fairly unique position during the early 1930s. It was one of the few companies that was A, large enough, and B, solvent enough to react to a sudden shift that occurred in the commercial aviation industry within the United States. Douglas had not abandoned his early ambition to produce a commercial airliner. But even before 1930, he had realized that the commercial air industry, as it was, had its limitations and was deeply flawed. Thus far, airline operators had relied heavily on government subsidies just to break even, let alone make a profit. And this put an emphasis on cheapness, which of course limited your design options and had knock-on effects when it came to, reliability and safety.
Additionally, most commercial aircraft of the time carried no more than 10 or maybe 12 passengers at a stretch, which meant that routes had to be flown cheaply, quickly, and very often to be able to justify themselves financially. This meant that most aircraft were flown hard, flown fast, and wore out very quickly, which led to a string of accidents throughout the 1920s. And so by the end of the decade, the popularity of air travel had not exploded as quickly as some, such as Douglas, may have initially expected. But all of this changed in 1931. On March the 31st of that year, a Fokker trimotor, which was carrying a beloved football star and coach, Knut Rockne, crashed in Kansas, killing all 8 people aboard, including Rockne himself. The accident and his death was printed across headlines all across the nation, and pretty much a state of national mourning took hold of the American public. However, the national state of grief quickly gave way to a national state of public anger at the obsolescence and total lack of safety when it came to commercial airliners. The effects of this accident were far-reaching. The details of commercial air accidents were no longer allowed to be kept secret. The Fokker trimotor fleet was grounded, to be followed by a slew of expensive modifications to bring them up to spec, and it was held in common belief that aircraft utilizing wood in their construction were far too accident-prone to be allowed for commercial air travel routes. In the wake of that accident, and following scrutiny by both sensationalists and more sensible heads, flying by air was generally deemed to be the least safe mode of transport in 1931 when comparing planes with trains, automobiles, ships, or even horses. And airline companies very quickly realized that their very survival was on the line and they needed to rapidly acquire better and safer planes. This is, of course, the start of a chain of events that would eventually lead to the development of the Douglas DC family of aircraft. But before we get into that, a bit of additional context is required to understand the full story. The success of the DC-1, and thus the DC-2 and the DC-3, was the result of a few contributing factors. As mentioned previously, Douglas Aircraft was in a good financial position. They had ready cash available, security in the form of existing contracts with the United States military, and although the company had gone public, Douglas still maintained a strict financial policy. Development costs had to be absorbed within a year, and overruns were almost non-existent. Thus, his company had the money on hand to react to a sudden change in market requirements. That's contributing factor number 1. Then there were the airlines themselves. Following a series of reforms that massively shook up the airline industry in the late 1920s, a topic that's far beyond the scope of today's video, but could ironically be summarized as multiple attempts to prevent monopolies, accidentally resulting in the forming of new monopolies, there were only 3 major airlines in operation: American Airways, Transcontinental and Western Air, also known as TWA, and United Airlines, with TWA and United being the largest of the 3. These 2 companies often shared lucrative airmail routes, but they were very serious rivals when it came to getting passengers, and both knew that the airline that got a newer and better aircraft first would have a huge competitive advantage. And so, in 1932, when United Airlines announced that they had ordered 60 of the brand new Boeing 247s, a revolutionary design that showed much promise, TWA became somewhat desperate. Especially when Boeing had then told them that they would have to wait for United to get their planes delivered before they could even order any for themselves. That's contributing factor number 2. Then, at roughly the same time as all of this was going on, Donald Douglas had assisted Jack Northrop in setting up the Northrop Corporation, a subsidiary of Douglas Aircraft, with Douglas holding a 51% stake. Northrop was joined by aeronautical engineer Ed Heinemann, a friend of Douglas, who had also done some work for the company, and who had a passion for developing high-performance aircraft. Heinemann was also on very good terms with Douglas's chief engineer, Dutch Kindleberger, and the two frequently exchanged ideas, notes, and reflections on the latest development in aviation tech. Basically, they liked to gossip a lot about planes. This close connection meant that Jack Northrop freely allowed the Douglas team to make use of innovative design features or technology that his team had developed. That's contributing factor number 3.
All of these factors would come into play following a letter sent out by Jack Fry. He was the Vice President of Operations for TWA, and he was desperate to find a new commercial airliner for his company. He'd sent letters and a design brief to Douglas, Martin, Consolidated, Curtiss-Wright, Sikorsky, and General Aviation. His letter to Douglas opened with the following: Transcontinental and Western Airlines is interested in purchasing 10 or more tri-motored transport planes. I'm attaching our general performance specifications covering this equipment and would appreciate your advising whether your company is interested in this manufacturing job. If so, approximately how long would it take to turn out the first plane for service trials? Donald Douglas would later on call this letter the birth certificate of the modern airliner, but at the time of receiving it, his response was tempered by the particularly tough requirements that Fry had outlined. It called for a transport that could carry at least 12 passengers, with more legroom offered than their existing fleet. It required a cruising speed of 145 miles per hour, a minimum service ceiling of 21,000 feet, a range of 1,080 miles, a maximum landing speed of 65 miles per hour, instruments for nighttime flying, and, most challenging of all, it must be able to take off with a full load and climb to cruising altitude with one of its engines switched off.
Upon receiving said letter, Douglas Aircraft carried out preliminary studies for an aircraft that could meet these requirements. At the time, Douglas's engineering team, with James Dutch Kindleberger as chief and Arthur Raymond as assistant, was well aware of the potential of the Boeing Model 247. But although Douglas himself believed that they should have a go at this project, he initially didn't want it to be their top priority. With the airline industry still in total disarray, and with the economy still looking a bit on the wobbly side, he foresaw that there was the need for maybe 100 of these aircraft for the entire US market, maybe as little as 50. And with military budgets recovering, he expected the company would make far more money from military contracts compared to commercial airliners. Yes, the company technically had the money to invest in both, but he wanted them to be cautious, and he hesitated on giving TWA a direct answer. Now, it is suspected, but not outright confirmed, that Dutch Kindleberger is the one who shifted the balance, and could well possibly be responsible for the DC-1 even existing. He was on good terms with Harold Talbot Jr., who was then chairman of North American Aviation, who also happened to be a major shareholder of Douglas stock. And the day after receiving TWA's letter, Douglas, who was still umming and ahhing about the whole thing, suddenly received an unprompted visit from Mr. Talbot, who promptly convinced him that the project was worth their full investment, and that Douglas Aircraft could possibly corner the market if they played their cards right. And so, putting aside his initial reserve, and drawing on the optimism that Douglas was so often known for, he assembled his design team and decided to go on a gamble and give the project the company's top priority. The full details of their design process, brainstorming, and interesting meetings will be described in a special video on the DC series itself. But, in a nutshell, the team spent several days drawing up the template for what would become the Douglas Commercial 1, aka the DC-1, and Douglas then sent the details to TWA for approval, and very narrowly beat out the competing designs that were being drawn up by Curtiss-Wright, General Aviation, and Sikorsky. The idea for the aircraft to be built as a trimotor was dropped at the insistence of both Kindleberger and Raymond. They argued that the nose engine, A, reduced pilot visibility by far too much, and B, caused far too much noise in the cabin. They would instead acquire the most powerful engines commercially available and couple them with new streamlined cowlings and variable pitch propellers to get the same amount of power. The cabin was to be roomy enough so that the average person could walk down the aisle without stooping, something that you couldn't do with the Boeing 247. It would also utilize the latest ideas and techniques for noise reduction, which was a real point of complaint for passengers during this time, and the DC-1 would utilize a new style of multicellular wing structure that had been developed by Jack Northrop. He had very kindly sent the drawings of this design over to Douglas for free use on any aircraft that he desired. This produced a wing that was both cheap to make but extremely strong, and this would account greatly for the longevity of the DC-1 and its descendants. The design, development, and testing of the DC-1 was a mammoth task for Douglas. Pretty much everything was developed from the ground up, and the team had spared nothing. Douglas himself had insisted on several features that made the DC-1 stand out from the rest. Its broad cockpit windows, which offered excellent pilot visibility, a soundproofed main cabin for passenger comfort, heating ducts for both the passengers and the pilots, a spacious lavatory at the rear of the cabin, and a small galley for the provision of food on longer air routes. Construction of the DC-1 took approximately 9 months, and then, powered by a pair of 690 Wright Cyclones, it made its maiden flight on the 1st of July 1933, taking off from Clover Field in Santa Monica. At first, things appeared to go poorly. The DC-1's engines appeared to struggle and then fail every time it was put into any sort of powered climb, and it took some considerable wrangling to get it back down to Earth in one piece. As it quickly turned out, this was no fault with the DC-1 itself, but rather with the engines, as the Wright Cyclones had had their carburetors installed backwards, which meant that every time the nose of the DC-1 was put up, gravity would starve the engines of fuel. Not exactly ideal. Thankfully, this problem was quickly corrected, and the DC-1 was soon flying again. Its biggest test came in September. One of TWA's conditions for the airliner was that it must be able to take off and land from their airfields with a full load under the power of just one engine. Back then, this was a considerable challenge to overcome, but Douglas were confident that the DC-1 could do it. And so, on September the 4th, the DC-1 took off for a flight from Winslow in Arizona to Albuquerque in New Mexico. After one of the engines had been switched off for the takeoff run, the DC-1 slowly climbed to a cruising altitude of 8,000 feet, and then it successfully completed the 280-mile route under the power of just one engine. Following the successful evaluation of the DC-1, TWA then placed an initial order for 20 improved versions. These had more powerful engines, and had the fuselage lengthened by 2 feet to allow 14 passengers instead of 12, and they would be produced under the designation of DC-2. The first aircraft made its maiden flight on the 11th of May 1934, and it began operating with TWA a week later. In service, the DC-2 quickly established an excellent reputation for itself. To Douglas's immense delight and relief, the DC-2 proved to be faster, more comfortable, and more economical than the Boeing 247, and overnight it became the best airliner flying in the United States. TWA were incredibly pleased with their new aircraft, of course, but they would not be the sole operator of the DC-2 for very long. Boeing had made a critical mistake in limiting the sales of the 247 until their initial order for United had been completed, shutting out other customers from the market. Douglas, on the other hand, reserved the right to sell the DC-2 to any other customers that chose it, so long as the production capacity of their facilities were not exceeded. At first, however, this production capacity was not too large, and it was in fact very expensive. After going over the numbers, Douglas was predicted to make a net loss on its first production of 20 DC-2s for TWA, and it had all come down to man-hours. Each DC-2 was essentially being hand-built, and it took over 59,000 man-hours to produce just a single aircraft, which represented a huge cost. Donald Douglas and his factory superintendent, George Strumpel, who'd been with him since the earliest days, quickly realized that they had but one option. The company had to get some really big hydraulic presses and stamp out the simpler parts like the factories were doing in the automotive industry. The plan worked. The required man-hours to build a DC-2 dropped from 59,000 to just 32,000, and the Douglas Aircraft Company had begun to take its first steps into the world of mass production, becoming one of the first aircraft companies to do so. Nevertheless, the company still made a loss on its initial order for TWA, but this was soon made up by income from many other orders instead. These came from other airlines within the United States military, as well as a number of overseas customers, with Fokker being the biggest foreign buyer, with Anthony Fokker himself acting as a sort of quasi-broker for other European carriers. In all, 3 main commercial versions and 8 military transport versions of the DC-2 would be produced, totaling just under 200 aircraft before production ceased. This far exceeded Douglas's initial prediction of being able to sell maybe 50 planes at most, and as it turned out, the company found itself breaking even on cost after the 75th DC-2 had been built. Though overshadowed by its successor, the DC-3, the DC-2 represented a paradigm shift in the aviation industry, and it was a huge boost to the image of the Douglas Aircraft Company itself. The DC-2's high performance was a particular point of praise, and this was especially highlighted when it came second in a 12,000-mile air race from London to Melbourne. The only aircraft to actually beat it there was a specially built de Havilland DH-88 Racer, and the flight gained worldwide attention because the DC-2 had so thoroughly outclassed competing designs by both Boeing and Lockheed, and other overseas manufacturers as well, that some wondered why they'd even shown up. Because of this, the DC-2 was declared the best commercial aircraft in the world, and later in 1936, Douglas was awarded the Collier Trophy, aviation's highest award, by President Roosevelt at the White House for its development. This development had not been cheap. The design and testing of the DC-1 and the placing into production of the DC-2 had tied up more than $2 million, of which $450,000 had been raised by loans. This represented a gamble by Douglas, as cash and marketable securities held by the company had dropped from $2 million in 1932 to just $650,000 in 1934, with about a quarter of that being pledged as collateral for the loans. At the same time as this, disappointing results achieved with the Dolphin, and reduced government orders, resulted in a drop in net income, going from an all-time high of $690,000 in 1930 to just $34,000 in 1934. Furthermore, the heavy cost of the DC-1 and the DC-2 development programs had forced Douglas to modify, for the first time, his company's policy of writing off the development cost of an aircraft within 1 year. And the development cost of this program was spread over the financial years of 1934 and to 1935. Because of this, only one other aircraft was developed by the company during the period that spanned from 1932 into mid-1934, and that was the XO2D1. This was the company's last biplane design, and it's perhaps one of their least known designs in general. Probably because it was a total failure. It was designed for a Navy competition to build a new scout plane to serve aboard cruisers and capital ships, and this was a competition in which it lost to the Curtiss XO3C1, which was the prototype for the SOC Seagull, another aircraft that we've already covered on this channel. Fortunately for Douglas, this didn't really affect things when it came to its reputation with the Navy, as several promising projects were already on the horizon, and even more fortunately, the heavy financial outlays of the DC-2's development were slowly being offset by a promising future. By the end of 1934, the company had contracts in progress that were worth $1.5 million, and early in 1935, they received delivery payments that amounted to approximately $600,000. With production of the DC-2 underway, more resources could now be spared towards the development of other aircraft types. Between the end of 1934 and the end of 1935, the company designed the XP-3D flying boat, the XTBD-1, which became the Devastator, which we've covered in its own video, the B-18 Bolo, which we've also covered in a video, and the DST, known as the Douglas Sleeper Transport, which would become the DC-3, which we haven't covered in a video yet, but I'll briefly go over its history now, as it's somewhat critically important to the success of the entire Douglas company in general. So yeah, let's take a quick look at that now. In the case of the DST, and its day transport version, the DC-3, the company actually failed to foresee the true potential market of this machine. Or rather, Douglas was a bit too pessimistic. On the 5th of May 1934, American Airlines had begun a new transcontinental service, going from New York to Los Angeles. This service flew over a longer route than its competitors, and so it offset this competitive disadvantage of the longer route by operating Curtiss Condors equipped with sleeping berths. But with United operating the faster Boeing Model 247, and with TWA rolling out the first of its even more faster DC-3s, it soon became very imperative for American to replace its Condors with something even better. As Douglas was currently wiping the floor when it came to commercial aviation and its competitors, the airline decided to approach them for a new design. They approached Douglas in late 1934 and asked him if his team could design a slightly wider version of the DC-2 that could accommodate sleeping berths for their new transcontinental route. Now, initially, this request was received with only lukewarm enthusiasm, as Douglas underestimated the value for such an aircraft, as these transcontinental routes were not particularly popular or profitable quite yet, and also because American was slightly concerningly short on cash owing to the unprofitability of said routes. But following a long telephone call between the president of American Airlines and Donald Douglas himself, during which an order for 20 aircraft was verbally promised in a sort of gentleman's agreement, Douglas decided to agree to the undertaking. At first, Douglas and American planned the DST as a minimum change version of the DC-2, with the two aircraft having about 85% common parts. However, it soon became necessary to abandon this conservative approach, and ultimately the DC-3 only used about 15% of the parts and components that were found on the DC-2. While this design philosophy resulted in a significantly higher engineering and manufacturing cost, it enabled Douglas to produce an aircraft capable of a great variety of civil and military roles. First flown in December of 1935, the initial DST could accommodate 14 passengers in its nighttime configuration, or 28 when used as a day transport. 14 wide double seats could be made up into 7 lower berths, and 7 upper berths folded down from the ceiling. These upper sleeping areas necessitated the installation of 4 small upper windows on each side of the main cabin, and this made the DST easy to distinguish. Initially, the first DST was only followed by about 37 other aircraft designed as sleeper transports. This limited production would have justified Douglas's earlier misgivings about the popularity of the type, but he was soon very much stunned by the rapidly growing popularity of the DST once it entered service, and this very quickly led to follow-up orders, and even more success would follow with the day transport version that had been designated as the DC-3. Within just 6 months of entering service, the new aircraft were already surpassing the commercial success of the DC-2. By the end of 1936, American Airlines had received 7 DSTs and 13 DC-3s. The first export aircraft had been sold to Fokker, and other orders were piling up at an incredible rate. In the United States, American Airlines was quickly followed by Eastern and United, who began operating the DC aircraft in 1937, and between then and 1940, 8 other major US carriers added either the DST, or the DC-3, or both to their fleets. The popularity of these aircraft grew at such a pace that by late 1941, of the 322 aircraft operated by the US domestic airline fleet, 260 of them were aircraft built by Douglas. The success of the DC aircraft was a direct reflection of the huge impact it had on the quality of air travel, which thus had an impact on the growth of the market. In 1934, the flight between New York and LA took 25 hours and 55 minutes. It involved a change of airlines, 2 changes of aircraft, and 15 stops. But when American introduced the DST, it was able to offer a single plane 3-stop service, which only took 17 hours and 30 minutes to complete. And this was a reduction in time of approximately 1/3, which was huge. Additionally, flying itself was far more enjoyable. Before the DC series, it was not uncommon for passengers to put either wax or even cotton balls into their ears to protect themselves from the loud noise of the aircraft's engines. Now, in the DC-2 and the DST and the DC-3, people could not only preserve their eardrums, but they could even engage in conversations that didn't require shouting. Not only did the DC-3 prove to be reliable and safe, but it also became the first airliner to return a true profit without the support of mail contracts or other forms of government subsidies. Unsurprisingly, the DC's popularity quickly skyrocketed. The company quickly received orders from most major European nations, as well as the Soviet Union and Japan, and members of the Commonwealth, and domestically within the United States, the DC-3's popularity introduced a whole new segment of the population to the new and exciting world of comfortable and safe air travel. The numbers really did speak for themselves. In 1935, the year before the DC-3's entry into service, the US domestic passenger mileage was 267 million miles per year. But in 1941, this had increased 5 times to 1.3 billion miles per year. But this growth was now receiving a check. By this point, overseas demand for the DC-3 had dropped off considerably due to the outbreak of the Second World War in Europe. In many areas, the airline services that had not been outright cancelled became an extension of the government and military transport systems, hauling troops, cargo, and mail. In the process, many of the European DC-3s were impressed directly into various armies or air services, where they would soon be joined by thousands of their military derivatives. Meanwhile, other DC-3s, especially in the United States and in various neutral countries, continued to operate until the end of the Second World War, where they were then joined by a massive influx of surplus aircraft, which would launch the aviation industry into an even more massive period of growth. But that's a topic for later. Putting aside the glory of the DC-3, it's important to take a look at the rest of the company's history in the lead up to America's involvement in the Second World War. The period of 1935 to 1940 was one of huge growth for the Douglas Aircraft Company. Net sales increased from 8.5 million in 1935 to almost 61 million in 1940. Net income went from 1.2 million to 10.8 million, and cash and marketable securities held by the company went from 1.7 million to 26 million. Also significant was the fact that, due to the increasing volume of commercial business, sales to the US Armed Forces, which up to and including 1933 represented 90% of Douglas's total sales, now only accounted for 54% of the company's total revenue between 1922 and 1939. But this growth did not only solely revolve around that of the DC-2 and the DC-3 transports. There were other factors at play as well. Not only did Douglas continue to work on various military, civil, and experimental designs, but the company had also acquired a new production facility. In 1932, John Northrop had formed the Northrop Corporation as a subsidiary company under Douglas, with Douglas holding a 51% stake, as I mentioned earlier. Its main production plant was established near the corner of Imperial Highway and Aviation Boulevard in El Segundo. Between 1932 and 1937, several different types of aircraft were produced there under the Northrop banner. Things such as the Delta, the Gamma, and the A-17 to name a few, all of which will be covered in its own video later. But in 1937, the company began to experience labour problems. These problems became so serious that the War Department then refused to work with the company until they were resolved. Douglas attempted to correct these issues by buying out the rest of Northrop and reorganizing it, but these efforts ultimately failed, and John Northrop would part ways to form a fully independent company, Northrop Aircraft Inc., in 1939. The Douglas Aircraft Company kept the facilities that had been left by Northrop, and these were reorganized into the El Segundo Division. The company had also inherited Ed Heinemann, who had worked with Douglas before, then with Northrop, and was now back in the fold with the Douglas once again. He would lead the team at El Segundo, which would soon become known for a successive series of carrier-borne aircraft that they built for the US Navy, beginning with the BT-1, earning glory with the SBD Dauntless, and culminating with the venerable A-4 Skyhawk. El Segundo would also provide the manpower and resources that would go into building other projects, such as the experimental Douglas XB-19, a truly massive superbomber whose expensive and innovative story has already been covered in its own video on this channel. Now, to further clarify why this video focuses more on the company rather than the aircraft, here is a list of the major designs that were either produced, or at least in the early development phase, between 1935 and 1940. There was the DC-1, the XO2D-1, and the DC-2, of course. There was also the YO-A5, the TBD Devastator, the B-18 Bolo, the Big XB-19, the A-8, formerly A-17, the BT-1, the DC-3, the C-47, the DF, the SBD Dauntless, the DC-4E, which eventually led to the DC-4, the DB-7, the A-20, and the B-23 Dragon. Needless to say, the company was kept very busy, and if I were to go over that in detail, it would take literally a day, and this busyness was also reflected in the life of Donald Douglas himself. Now a father of 5, he faced an endless struggle to balance the responsibilities of parenthood and that of running a rapidly growing business. From 1935 onwards, the family vacations that had marked many weekends of his earlier years became exceedingly rare, and Douglas found himself putting in long hours, managing up to a dozen different projects at once, and overseeing the general running of the company. His wife and children were of course completely supportive, and indeed, his daughter Barbara attended many public events, christened various aircraft, and in general took over a lot of the public relations roles that her shy mother was more than happy to surrender. But on the whole, the success of the business had led to a strain in the family relationship. Now, this certainly had an influence in the explosive fight between Donald Douglas Sr. and Donald Douglas Jr. that occurred in 1938, and for the purpose of simplicity, we will refer to Sr. as Douglas and Jr. as Don. Naturally, in these more traditional times, the argument was because dear father did not approve of his son's choice for a wife. In fact, Douglas was so furious that the wedding went ahead that he all but disowned his son and refused to let him come and work for the family business. Don Jr., though vastly different from his father in personality, had at least inherited his father's more practical traits. He quickly landed a teaching job at the Curtiss Wright Institute. There, he developed innovative teaching aids to assist students who struggled with reading technical blueprints. From his own upbringing, he understood that people learn differently, and a mix of physical, visual, and spoken teaching techniques made his classes some of the Institute's most successful during his tenure.
But, as much as he enjoyed it, he could not settle down with his wife on the modest salary that the Institute provided. And so, 3 years after all but severing ties with his father, he walked into the Douglas Employment Office and applied for a job. Going directly to father himself was out of the question, and Don wanted to get in on his own merit anyway. But his father clearly recognized that his estranged son had promise, because Don's application was quickly accepted. He would spend the war years working on several projects, notably the C-54 transport, but Don Jr.'s time would not truly come until after the war had ended. Getting back to the company itself, a big milestone was celebrated in 1939, which marked Douglas's 25th anniversary in the world of aviation. To honor the event, Douglas decided to host a private party in the skies, and the platform selected for this was their newest flagship, the Douglas DC-4. The DC-4 had been inspired by, but was not developed from, the more expensive Douglas DC-4 Experimental, more commonly known today as the DC-4E. This had not been a project initiated by Douglas, but was once again a reactionary measure to interest expressed by the commercial aircraft industry. In the mid-1930s, Donald Douglas had been approached by W.E. Patterson, now appointed head of United Airlines. Patterson wanted Douglas to develop a new four-engine airliner, one which could fly coast to coast without refueling. Patterson was an enthusiastic supporter of the DC-3. However, he had approached Boeing first with his proposal, partly out of loyalty as he used to work for them. But Boeing weren't interested. They were too busy building a four-engine flying boat for Pan American, intending to carry passengers across the Atlantic or Pacific Oceans, and their ignorance of Patterson would prove to be a costly mistake. When Patterson approached Douglas, he explained that he knew exactly what he wanted, and that he had already asked the United Aircraft Company in Hartford to help with power plant development. He had already brought in several engineers to consult and advise on their requirements, including Douglas's old mentor, Jerome Hunsaker. Donald Douglas and Arthur Raymond sat down at another meeting with Patterson and expressed their interest, but also their concerns, namely cost. They had estimated that the first prototype aircraft would cost around $600,000 to design, build, and test, a truly monumental sum for a civil aircraft in this period. But Patterson's response was as unexpected as it was convincing. Not only did he guarantee to foot half of the total development cost, joking that he could write up a check for $300,000 on the spot if they really wanted it, but he also brought the financial support of TWA, American Eastern Airlines, and Pan American. Unknown to Douglas at the time, these hotly competing airlines had long been in communication about the future, and although they were commercial rivals, they had realized that they risked complete bankruptcy if they tried to finance an endeavor of this scope on their own. Thus, they had agreed to not finance any other large commercial planes until the Douglas design had been built and evaluated. Unfortunately, the enthusiasm of these airline companies would doom the DC-4E to become a one-off design. It flew for the first time on June 7, 1938. It had taken 500,000 working hours to design, plus a further 100,000 working hours of ground and lab testing. Douglas's initial cost estimate was almost exceeded by a factor of 3, with the total cost of the DC-4E's development topping out at $1.6 million. A lot of this was because the aircraft was so far ahead of anything else in its class. It had a massive wingspan of 138 feet, and a cabin length of 97 feet. It required power-boosted controls. It had full climate control, underwing refueling, and it featured a tricycle landing gear, something that wouldn't become commonplace until after the Second World War. Unfortunately, though innovative, the DC-4E itself wasn't particularly, good. It had stability problems and suffered from a high rate of maintenance problems. A lot of this was the result of input from the airliners who helped finance it. Their contribution had required that any design challenges had to be resolved by the decision of a joint committee, and, as a result, that had led to far too many compromises. In a nutshell, the DC-4E was good, but it wasn't great, and it certainly wasn't worth the huge price tag. However, it wasn't a complete lost cause. Important lessons had been learned, and the interest from commercial airlines remained strong, if only cost and reliability could be improved. Donald Douglas decided that the design team should start with a clean slate. They should borrow some aspects of the DC-4E that worked, and build something a little less cutting-edge and a little more practical. The result was the Douglas DC-4, which sounds a little confusing as it shared almost nothing in common with the DC-4E aside from the use of a tricycle landing gear. Though 25% lighter than the DC-4E, it would still accommodate 40 passengers, a big upgrade on the DC-3, and it received enthusiastic support from America's commercial airlines, who were quick to put in orders. However, most of these orders would not be fulfilled for a long time, as, a few months later, the outbreak of the Second World War would change everything. But, for the immediate moment, that future had yet to arrive, and it was in the hope of producing many peacetime commercial aircraft that Donald Douglas was flown up in one of his first DC-4s. It circled the cities of Santa Monica and Los Angeles, where the company had grown and prospered, and Douglas was joined in the air by his father, close friends, and several of the original founding members of the company, such as Bill Henry, David Davis, Henry Guerin, and George Strumpel.
In the previous 5 years, the company's growth had been phenomenal. The number of employees had grown by 10 times, reaching a total of 9,000, and Douglas Aircraft had achieved international success on a level that Douglas himself would have considered fantasy just a few years previously. But this happy achievement and this happy year was marred by two things. The outbreak of the war in Europe was about to present a litany of logistical challenges for the company, and Douglas himself realized that his country's involvement in this war would be a matter of when, not if. And then, in December of 1939, he learned that Anthony Fokker, one of his closest friends, had suddenly died after a short illness. Douglas and Fokker had been good friends from the outset. They both shared a love for sailing and the sea in general. Both were passionate designers of aircraft, and yet they never considered each other as true rivals, though they both built commercial designs, and Fokker's death deeply upset him. It left a lasting impression, reminding Douglas of the fragility of life and the importance of legacy, and this was one of the things that would drive him to remain involved with the company until his final days. Though he deeply missed his friend, Douglas was soon forced to put grief aside, as the busiest period of his life, and his company, was about to begin. The war years began with Douglas Aircraft in a very strong position. 1939 marked the company's 11th and most profitable year. It had achieved a net income of just under $3 million, and its backlog of orders had grown considerably. In 1929, the company's backlog was worth $2.3 million. This had then grown to $31 million by 1937, and then it had more than doubled to almost $69 million by the end of 1939. The breakdown of this backlog painted a clear picture of the sudden shift in political climates, and the violent reality being faced by much of the world. 58% of Douglas's orders were now for export orders for military aircraft, 34% were for the US War Department itself, and just 8% were for the civil and commercial markets. By this point, the DC-2 and DC-3s were used by all the major airlines in the United States, and by 18 major airlines overseas. They were being built domestically and under license, but they did not dominate the Douglas production lines in 1939 as much as some would expect. That would come with the C-47 Skytrain starting in 1941. No, in 1939, the bulk of Douglas's production was focused on the export DB-7, the A-20, the B-18 and the B-23 for the Air Corps, and the TBD Devastator for the Navy, with the company also tooling up for the production of the SBD Dauntless. But with the war in Europe rapidly escalating, spreading into the Mediterranean and into Africa, and with the worsening political situation with Japan, the production and development of Douglas's military planes skyrocketed as the US Army and Navy began to place massive orders. Orders which the company had zero chance to meet with its current facilities. This was a problem faced by the entire industry as orders piled up by the thousands for both export and domestic aircraft, and when in May of 1940 President Roosevelt called for the production of no less than 50,000 aircraft per year, the US government initiated its Emergency Plant Facilities Program. This is a topic that will get its own video, as the logistics behind it are staggering and remarkably interesting. But in a nutshell, the aircraft manufacturers would build whatever facilities they needed, and the US government would reimburse them over a period of 5 years. Following this, they would then assume ownership. This meant that the government didn't financially cripple itself on day one by financing several dozen factories at once, and it meant that the manufacturers could later be relieved from assuming the risk of possessing an expensive and excessive amount of factory space after the war had wrapped up. For Douglas, this led to the development of their Long Beach facility, which was built adjacent to the Long Beach Municipal Airport. As work on this new factory got underway, Douglas received the first of several massive orders for the C-47, the military version of the DC-3, along with follow-up orders for the A-20. These were produced at the Santa Monica facility, and over at the El Segundo Division, the production of the SPD Dauntless was dramatically accelerated, and, several thousand miles away, the temperature in the command bridges of several Japanese fleet carriers magically dropped by several degrees. In November of 1931, the Long Beach plant would begin its operations, with its first aircraft assembled being a C-47DL. Attending its grand opening was the massive XB-19 experimental bomber, and the scale of this flying behemoth was an excellent reflection on the capabilities of Douglas's new factory. During the next 3.5 years, the Long Beach plant would produce variants of the C-47, the A-20, the A-26, and the B-17, all at the same time. By the end of the war, its production capacity had far outpaced all other Douglas facilities, and Long Beach alone produced some 9,439 aircraft, or roughly 9 every day around the clock during its operations. Meanwhile, Douglas's main plant at Santa Monica continued production of the C-47, the A-20, and the new C-54 Skymaster. But it also housed most of the company's design facilities, and so it oversaw the production of new designs as well. Some of these new designs drawn up included the XB-42 Mixmaster, which later evolved into the jet-powered XP-43. Work began on the XC-112 project, which sought to develop a larger and pressurized version of the DC-4 as a military transport, which would eventually emerge after the war as the DC-6, and numerous other design experiments were initiated that would bear some interesting results in the post-war period. Though Douglas Aircraft was now pumping out a frightening amount of airframes across its 3 big facilities, it was still not enough to keep up with the urgent demands of the Allied forces, for which Douglas was now becoming the main supplier. Because of this, the company once again turned to the US government to assist with the construction of even more production facilities, and this resulted in the sponsored construction of factories in Chicago, Oklahoma City, and Tulsa. Used exclusively to supplement the Santa Monica plant in C-54 production, the Chicago facility began operations on October 1, 1943. Likewise, the Oklahoma City plant was used exclusively for the production of the C-47, but the Tulsa plant, which had initially been intended for contracted production of the B-24 Liberator, instead found itself producing the Douglas A-26 and the A-24 Banshee, which was an Army Air Force version of the Navy's SPD Dauntless. The result was that by the end of the war, Douglas was one of the 2 biggest aircraft manufacturers in the entire United States. North American aviation had produced more airframes, churning out 41,000 versus Douglas's 31,000, but Douglas had produced more in terms of pure mass. From January 1st, 1940, until December 31st, 1944, the company had produced 140,000 tons worth of aircraft, which was 15% of the entire nation's production during the war. On its own, this was a deeply impressive feat, but this production had also brought with it a lasting legacy. Douglas was already a well-known name by the time that the war had arrived, but now it was firmly solidified as one of aviation's all-time greats. In the early, desperate opening year of the Pacific War, the Douglas SPD Dauntless fought in every major naval battle. It sank 300,000 tons of Japanese shipping, more than any other aircraft, and is credited with the sinking, or the assistance of sinking, 15 transports, 1 submarine, 6 destroyers, 14 cruisers, a battleship, and 6 aircraft carriers, many of which were sunk at Midway, which was the Dauntless's most famous action of the Pacific War. The Douglas A-20 Havoc established itself as a reliable, strong, and surprisingly nimble attack aircraft. It was easy to learn and it was beloved by British and Soviet pilots especially. In fact, the Soviet air forces eventually operated more A-20s than the Americans did themselves. And, of course, there was the C-47 Skytrain, of which over 10,000 were built. This wartime version of the DC-3 was utterly vital to the logistical success of many Allied campaigns, in particular those in the Pacific and Southeast Asia, where reliable aerial supply was of critical importance. It was a frequent sight all over the world, hauling supplies, troops, wounded personnel, or even towing invasion gliders, and the Skytrain was considered to be the most influential non-combat aircraft of the entire war. These aircraft and others had solidified the reputation of what was now a truly massive enterprise. At the height of its wartime production, the Douglas Aircraft Company employed over 160,000 employees, and in 1944 alone it produced $1 billion worth of aircraft. It had risen to the challenge of wartime demands, and it had exceeded all expectations. But, as it would turn out, the first years of a new peace would prove to be just as difficult as those of war. Donald Douglas and his company would face 3 major challenges in the late 1940s. Firstly, the cancellation of all major government orders following VJ Day would lead to a massive reduction in the company workforce, with over half of the staff laid off within a matter of weeks. Secondly, the company, like several others, found itself playing a hasty game of catch-up, as much of America's aviation industry had lagged behind technologically, as they had focused on producing as many existing aircraft as possible during the war, rather than focusing on innovating new things. The advent of the jet engine, the development of pressurized cabins, and many other innovations meant that the competition between airliners had essentially been reset in the post-war period. Douglas couldn't rely on the advantages it had before the war, and with reliable military contracts disappearing overnight, it had to be very careful with how it would invest in technology moving forward. And thirdly, Douglas would have to deal with the problem of its own success, which had, strangely enough, come back to bite it. The DC-3 and the C-47 were hugely successful, but following the war, a very large number of these were flooded into the civil market as the military was ditching all of its surplus airframes. This would force Douglas to push even harder to produce new innovative designs, as it was essentially competing with itself. These challenges would open the final chapters in the Douglas story. It would see some of the company's greatest success stories and some of its biggest failures. It would witness the birth of the jet airliner, the wars in Korea and Vietnam, the breaking of the sound barrier, the advent of cruise missiles, the invention of guided air-to-air weapons, advanced radars, early computer systems, and a whole string of other things that would make modern aircraft as advanced as they were costly. It was also a time that would see a change in the guard, a time for Donald Douglas to step back and try to take some of the immense load off his shoulders. But letting go of a company that you'd built up from nothing was easier said than done, and the complex relationship between Douglas Sr. and Jr., the ever-expanding divisions of the company, and the rapidly changing demands of a modernizing world would eventually culminate in a financial apocalypse, with the McDonnell Corporation coming in to the rescue. On VJ Day itself, Douglas received a telegram. It told him that the government was immediately cancelling most of its existing orders. Orders that had been so great in size that they had necessitated the operation of no less than 6 manufacturing plants. Douglas had known that this day was coming, and he had been preparing for it for some time, but even so, the end of the war came far earlier than he had expected, and he was faced with the sudden challenge of shrinking his company in rapid time.
The result was that within just a few short weeks, the leasing of the plants in Chicago, Oklahoma City, and Tulsa was stopped, with the government stepping in to acquire the facilities as originally planned, and over 90,000 people were laid off from the Douglas workforce. Though it had also been built under the Wartime Emergency Plant Facilities Program, the Long Beach plant wasn't given over to government control. Not all existing orders had been cancelled, and enough C-74s were on order to justify Douglas purchasing the majority of this plant in November of 1946. Though Long Beach and the other facilities had produced an astonishing amount of aircraft during the war, the Douglas Aircraft Company itself had not massively grown from the standpoint of finance. Combined profits from the war years amounted to just 1.5%, and this left Douglas with fewer reserves of cash than he could have wished for the lean post-war years that were now his company's new reality. The history of Douglas's immediate post-war years, which take things to the outbreak of the Korean War, are in some ways a mirror image of the later interwar years. Whereas before, Douglas relied on orders for tried and tested commercial designs, whilst experimenting with various military projects, it now relied on tried and tested military designs and had to get inventive when it came to airliners. Of the military designs, the ones that were still on order in quantity were the C-54 Skymaster and the A-1 Skyraider. Though, I say in quantity, it didn't really amount to much. For comparison's sake, the company had produced over 11,500 aircraft in 1944, but in 1946 it built just 127. Small wonder they had to lay off over 100,000 people. But although only a handful were produced in 1946, the new Skyraider was an aircraft that held much promise. The origins of the Skyraider came from a wartime need to replace the Douglas SPD Dauntless, which, whilst an excellent aircraft in its own right, was still a pre-war design. Douglas had initially lost out on a chance to produce a replacement, as Curtiss Wright had won a contract for the SB-2C Helldiver, but, as some people will know from the video where we covered the interesting history of that particular aircraft, things did not go too smoothly, and the Navy sought out alternatives in case a replacement was rapidly needed. Now, this initially resulted in the abortive Destroyer, which will get its own video in the future, but following meetings between Douglas engineer Ed Heinemann and Rear Admiral Lawrence Richardson, the company was given yet another reprieve to submit a new design in the summer of 1944. This reprieve did come with something of a caveat. Heinemann could submit a new design to the Navy, certainly, but it had to A. Make use of the powerful Wright R3350 duplex Cyclone, a twin-row supercharged 18-cylinder radial, and B. Heinemann had to submit this new design proposal by 9 AM the following day. After working until 3 AM, when exhaustion forced them to quit, Heinemann's design team had put together just enough for a reasonable design proposal, and the next day it was submitted to the Navy and was subsequently approved. With the SPD Dauntless out of production, this reprieve was a lifeline for Heinemann and the Segundo Division, who, at the time, were in danger of having 0 naval contracts by the end of 1945. Because of this, every conceivable effort was put into making this new design superior to the competition. This competition included the Kaiser Fleetwing XTBK and the Martin X-BTM. Both of these aircraft were highly advanced and featured very high payload capabilities. Heinemann realized that to be successful, their design not only had to be able to carry more, but it also had to be lighter, better performing, and, most importantly, in the emerging world of highly complex power plants, it had to be as simple and as reliable as possible to maintain. This design philosophy would eventually pay dividends, because over 3,000 Douglas AD-1s would eventually be produced, against just 151 Martin AM Maulers, and just 5 of the Kaiser Fleetwing prototypes. The Skyraider proved to be exceedingly reliable and capable, and because of this it remained in service far into the jet age, not being retired from service in the US until the mid-1970s.
The success of the AD-1 was one of Douglas's biggest financial assets in the sparse years that spanned 1946 to 1950, and it helped to particularly offset some dramatic investments that the company was beginning to make in the commercial market. In this market, Douglas faced two major sources of competition. The first was, ironically, its own success. Following the war, large numbers of C-47s and C-54s, the military variants of the DC-3 and DC-4, went up for sale as surplus. Naturally, a large number of these were acquired by various airlines around the world, who promptly converted them back to their commercial specifications. Now, whilst this did provide Douglas with some security, as they could at least manage the provision of spare parts, it did provide them with a challenge for developing a brand new airliner. They had to A, produce something significantly better than their existing designs, but B, produce it at a competitive price point that skirted very close to the line that separated profit from loss. This challenge was further exacerbated by the other major source of competition, and that was designs being built by Lockheed and Boeing. In 1943, the prototype Lockheed XC-69 had made its first flight, and now in the post-war years it was being adapted for commercial use as the L-049 Constellation. Similarly, Boeing was working on their Model 377 Stratocruiser, which was a commercial variant of the C-97 Stratofreighter, which itself was a transport version of the B-29 Superfortress. Both of these designs represented a significant commercial threat. Not only were they both equipped with pressurized cabins, which the Douglas's flagship DC-4 lacked, but they also had significantly faster cruising speeds, and they could carry at least 30% more passengers and cargo over longer distances. Douglas's attempt at matching the competition of numerous and cheaper surplus aircraft was to modernize and improve the existing design of the DC-3. Meanwhile, the company would address the threats from Lockheed and Boeing by converting an abandoned wartime army transport, the Douglas XC-112. At the time, it was said by some that the only replacement for the DC-3 would be another DC-3. This was an opinion held by several airliners, and to a degree by Donald Douglas himself. However, the airlines that wanted an improved version of the DC-3 were ones that were more focused on short and medium-distance flights, and Douglas's own opinion reflected his financially conservative mindset. Douglas was not one to often take financial gambles, and he believed that the demand for twin-engine airliners like the DC-3 would still outpace that for the larger, faster, and more expensive four-engine designs that had gradually emerged. The result was the development of the DC-3 Super, or DC-3S for short. It was to be faster and more capable than the original DC-3, while at the same time maintaining the same levels of comfort, safety, and efficiency. To achieve this, numerous modifications had to be made. The aircraft had a lengthened fuselage, bringing the passenger capacity up to 30. The engines were upgraded to the Pratt & Whitney R2000s, which were used on the DC-4. The fuselage was strengthened, and, to account for the shift in the centre of gravity and improve performance, the wingspan was slightly shortened, and the outer sections of the wings now had a sweep back of 4 degrees and squared-off wingtips. Though the DC-3S did indeed provide a marked increase in performance and capability over the original DC-3, it was not a competitive success. The design team had underestimated the amount of modifications that would be required to achieve the new performance figures airlines wanted, and the result was that the DC-3S only shared about 25% common parts with the original DC-3, and this of course made it too expensive. In the end, most major airliners either continued to use existing DC-3s, or they upgraded to newer, bigger, faster designs that were being offered at a more competitive price point. The DC-3 Super wasn't a complete loss though, for once again the US Navy had come in to save the day. Around 100 aircraft were eventually ordered as the R-4D, which came in several different variants. Some of these were used as staff or VIP transports, some were specifically modified as cold weather transports, several were used as training aircraft, and a few were modified to carry radar countermeasure equipment. Now, while Douglas struggled with the DC-3 Super, it fared much better in its head-on competition against Lockheed and Boeing. Here, the playing field was fairly even. Each company was trying to repurpose an existing World War II design for the post-war commercial market, and in this particular battle, Douglas would come out on top with the DC-6. Its origins went back to the DC-4. Even before the prototype had flown, Donald Douglas, Ed Heinemann, and Arthur Raymond had been contemplating the idea of fitting a passenger transport with a pressurized cabin. But at the time, the cost of doing so was prohibitively expensive, and a large amount of research and development would have to be invested. The company was doing well with DC-3 sales and pre-sales of the DC-4, but it couldn't justify that level of expense. Then, the huge demands of the Second World War put paid to any further considerations for commercial transports, and they got to work designing military transports instead. But they didn't abandon the idea of using a pressurized cabin, and when the Army funded a program to improve the C-54 Skymaster, the militarized DC-4, the Douglas team submitted a proposal for a pressurized prototype known as the C-54E. Ordered as the XC-112, it was longer and had more powerful engines than the standard C-54, and it featured other systems that were required for operations at high altitudes, such as a more powerful de-icing system for the wing leading edge. In general, the aircraft was a big improvement over the old C-54, but the war was over before the type had a chance to go into production. By this point, Douglas was aware of the developments over at Lockheed and at Boeing, and, seeing the promise held by their new pressurized transports, he organized for the XC-112 to be modified into the company's first pressurized airliner. Redesignated as the DC-6, it made its first flight in its commercial configuration on the 29th of June 1946. Even before its first flight, Douglas had received interest from both United Airlines and American, who were both equally concerned as their main rival, TWA, had secured priority orders for the competing Lockheed Constellation. Despite the sharp increases in development and production costs, when compared to the unpressurized airliners of the interwar period, Douglas was surprised to find that they had over 100 DC-6s on order by the end of 1946 alone. The type entered service simultaneously with United and American in November of that same year, and Douglas was soon flying out to the head office of Pan American to personally close the sale of even more. Boasting huge performance and comfort improvements over the DC-4, and with the aid of a strengthening world economy, the DC-6 became an instant success. Though the Lockheed Constellation was the first to enter service, Douglas's DC-6 quickly overtook the domestic market for sales by the end of 1946, though the type didn't enter service until the following April, and interest was rapidly growing overseas as well. This lead in sales was then quickly reversed in the opening months of 1947, then bounced back to Douglas by the summer, then bounced back to Lockheed by the autumn, and the two companies found themselves locked in the biggest commercial battle in the age of the piston-powered airliner. Now, Boeing, on the other hand, had missed the mark with its Stratocruiser, whose operating costs had put it far behind. On average, it was just over twice as expensive to operate when compared to the DC-6. It was troubled by reliability issues, which exploded its maintenance costs, and in the end only 56 would be delivered as commercial airliners. Although the DC-6 was off to an excellent start, the whole program was almost brought down in October of 1947. That month, a United Airlines DC-6 had suddenly caught fire above Bryce Canyon in Utah, and it had gone down, killing all 52 people on board. A thorough examination of the Utah crash had revealed that the fire had started somewhere in the lower fuselage, but its true cause was unknown. At first, it was thought that it may have been due to something volatile being stowed in a passenger's luggage, but then, less than a month later, another DC-6 was almost brought down by fire as well, but this one was able to make an emergency landing in New Mexico before the fire reached a critical point. Following this incident, Douglas immediately grounded the entire DC-6 fleet, and he sent Arthur Raymond and a team out to New Mexico to aid in the investigation. They soon found that the fire had been caused by an unexpected design flaw.
the team discovered that a fuel tank transfer switch had been left on during the flight. Although this was not recommended procedure, it was also not strictly barred by any formal directive. Now, if the switch was left on, and if one of the tanks were overfilled during ground refueling, it could cause excess fuel to overflow through a vent. At certain altitudes and air pressures, this was even more likely, and if the fuel did overflow, it trickled down to a point in the wing where it was sucked into an intake for the cabin heating system, which of course would then cause the fuel to ignite. The solution to the problem was, in the end, quite simple. The fuel vents were moved further out to the outer tips of the wings, which solved the issue. But the tragic affair had deeply disturbed both Douglas and Raymond. Douglas demanded a thorough overview of the entire design of the DC-6, and if anything was found to pose even a remote fire risk, it had to be changed. This resulted in many small changes that cumulatively made the aircraft much safer. After this, the only DC-6s that were ever lost to fire were the result of either poor aircraft maintenance or other external factors, rather than something wrong with the design itself. Production of the DC-6 ended in 1958, by which point the Douglas Aircraft Company had produced over 700 models over several different commercial and military variants. Once again, the demand for the type had far exceeded Douglas's modest expectations, much like with the DC-3, and the company had well and truly emerged as the winner between Boeing, Douglas, and Lockheed in the battle of the piston airliners. However, the success of the DC-6 was, ironically, one of the many things that would lead to the company's eventual downfall. It reinforced Douglas's conservative mindset that modernizing and improving existing designs often provided far better returns than designing a new, innovative, and expensive commercial aircraft from the ground up. And this would be a large contributing factor in the company's somewhat delayed entry into the jet age, at least when it came to airliners. Now, when it came to experimental and cutting-edge military aircraft, Douglas was far more enthusiastic. Though the late 40s were lean years, as far as military contracts went, there was still enough work going around to keep things ticking over, particularly for the Segundo Division. This was a period of rapid technological transition, and this was reflected by the various military and experimental aircraft that were developed there between 1945 and 1950. The experimental XB-43, which was a redesigned version of the XB-42, first flew in May 1946, and it was the first jet-powered bomber to fly in the United States. It would not go into production, but it did aid in the company's development of laminar flow wings, the development of new avionics systems, and it exposed Douglas engineers to the benefits, and the various drawbacks, of the new turbojet engine. Other, more successful endeavours quickly made up for this early disappointment. In 1945, the US Navy, in collaboration with NACA, launched the D558 National Research Project. This effort led to the creation of the Douglas Skystreak, a revolutionary aircraft designed to explore the mysteries and dangers of transonic flight. With its thin wings and a General Electric TG-180 turbojet engine, the Skystreak carried a single pilot and 500 pounds of instrumentation. Designed by Ed Heinemann's team, the Skystreak introduced groundbreaking innovations. It was built to endure forces of up to 18 Gs, which was far greater than any other aircraft designed at this time. It also had to tackle the challenges of aerodynamic heating. At speeds in excess of 600 miles per hour, the aircraft's structure could heat up by 64 degrees above the surrounding air temperature. Without advanced air conditioning units, its V-shaped cockpit enclosure would have reached a scorching 170 degrees Fahrenheit, and even with said cooling systems, temperatures inside often climbed to a very uncomfortable 100 degrees. The Skystreak took to the skies for the first time on May 28, 1947, piloted by Douglas test pilot Gene May. Painted in a striking red, the aircraft made a graceful but short flight, cut short by engine problems that delayed further testing until August. Once said issues were resolved, the Skystreak proved its worth. It reached Mach 0.85, firmly entering the transonic speed zone. It soon captured worldwide attention. Commander Turner Caldwell from the Navy's Bureau of Aeronautics set a new world speed record, reaching 640.7 miles per hour over a 3-kilometer course. And a few days later, Marine Major Marion E. Carl of the Naval Air Test Center pushed the Skystreak even further, achieving 650 miles per hour. But unfortunately, the Skystreak's story was then tragically cut short. On May 3, 1948, NACA test pilot Howard Lilly was killed when the aircraft lost power shortly after takeoff. The crash was traced to the failure of the TG-180 engine turbine blades. Despite this loss, the Skystreak had already exceeded the expectations of the project. It had even come close to breaking the sound barrier, reaching Mach 0.99 in a shallow dive on October 14, 1947. Ultimately, though, the Skystreak would be overshadowed by the Bell X-1, a rocket-powered aircraft which would become the first such machine to breach the sound barrier. But, not long after work had begun on the Skystreak, Douglas had proposed an even faster aircraft to the US Navy. Heinemann's engineering team suggested an advanced design that combined jet and rocket engines, which they believed could achieve speeds twice that of the speed of sound. And so, at a time when most aircraft factories were winding down operations, Douglas received approval to move forward with the second phase of the D558 research program. The new aircraft, called the Skyrocket, began to take shape at the company's El Segundo facility. It featured a reaction motors rocket engine to boost a jet engine which had 3,000 pounds of thrust. The design called for 3 research vehicles, each with swept wings and side-mounted air intakes for the jet. While the wings were conventional, the tail surfaces were thinner and swept back an additional 5 degrees to prevent control problems at high speeds. The first Skyrocket was completed quickly, and it made its maiden flight on February 4, 1948, marking the start of a multi-year testing program. Early flights began with the jet engine powering takeoff, followed by the rocket engine for high-speed, high-altitude test runs. Between 1949 and 1951, the Skyrocket completed 122 flights before being transferred for NACA for advanced testing. As the program evolved, NACA officials pushed to air-launch the Skyrocket, similar to the Bell X-1, to maximize its performance at high altitudes. This led to modifications on the second Skyrocket, allowing it to be released from a modified B-29 bomber. After successful testing, the same upgrades were made to the third aircraft, setting the stage for its role in pushing the boundaries of supersonic flight. Over the next 2 years, these experimental aircraft set numerous records. Of note, in November 1953, Scott Crossfield flew the Skyrocket beyond Mach 2, becoming the first pilot to fly twice the speed of sound. And 2 months later, a new altitude record was set, with Major Marion Carl reaching 83,235 feet. Donald Douglas considered the project one of his company's proudest achievements, and Ed Heinemann's team freely shared their data with the aircraft industry to further advance the development of research aircraft. And, in the wake of the tragic loss of the Bell X-2, to improve the standards of safety. The Skyrocket also saw some key involvement from Donald Douglas, Jr., who had been rising through the company ranks and was now head of flight test operations. The development of the Skyrocket, and that of several other projects, highlighted the younger Douglas's keen interest in the cutting-edge aerospace developments being made, and he would play a major role in spurring the development of some of the company's most advanced projects in the 1950s and 1960s. At the same time that development of the experimental Skystreak had begun, the El Segundo Division had also begun work on the company's first mass-produced jet aircraft. In 1946, Douglas was awarded a contract to build the F3D, and like many before, this was a contract issued by the US Navy. Its Bureau of Aeronautics wanted a twin-engined, carrier-based night fighter, and one that came equipped with an airborne radar that could detect the enemy at a range of 125 miles, whilst flying at 40,000 feet at an average speed of 500 miles an hour. Owing to these very lofty requirements, what would become known as the F3D Skynight had a very troubled early development. Early airborne radar was very bulky, and it necessitated compromises when it came to the size and shape of the airframe, something which resulted in much bickering between Ed Heinemann and various representatives from the Bureau. This bickering then turned into considerably heated arguments when the J-34 engines underperformed, and on numerous occasions Heinemann had to repeatedly explain that the prototype's lackluster performance was a result of the engines being bad, rather than the aircraft producing too much drag. Eventually, the problems were mostly overcome when the F3D-2 entered into production. With improved engine performance and the latest onboard systems, some of which were a little smaller than those on the prototype, the Skynight was one of the best military aircraft in the world in 1951. During the Korean War, it would down more enemy aircraft than any other in the US Navy, and it became the first fighter to secure a kill at night using a radar without any visual identification of the target. The F3D, and the Douglas Company at large, was also a key player in the development of what would become the AIM-7 Sparrow. Starting with projects in the Second World War, Douglas had begun to expand into the development of both guided and unguided missiles, as well as more powerful designs that were intended to explore outer space. Now, the development of these various systems is technically beyond the scope of today's video, as we're mostly focusing on aircraft, but I will give a brief account of the major involvement of Douglas when it came to this sort of technology, as it did form a not insignificant chunk of the company's revenue during the 1950s and 60s. So, in no particular order, I'll cover it briefly. The company was part of the collaborative effort to develop the Nike Ajax surface-to-air missile, being responsible for the aerodynamic studies and the design of its airframe. It played a key role in the development and production of the early iterations of the Sparrow air-to-air missile, as mentioned before, and it also explored the development of active radar homing systems. In the field of space rocketry in particular, Douglas designed and manufactured the second stage of the bumper sounding rockets, which were very heavily modified versions of the V-2. But the company's biggest claim to fame was its work on the larger launch vehicles of the 50s and 60s. Douglas developed and produced the PGM-17 Thor, which was the United States' first operational ballistic missile. Though it was quickly eclipsed as a weapon of war with the emergence of ICBMs, the Thor became the foundation of the family of Delta rockets, with NASA and Douglas signing a contract in 1959. Though the military models were dogged by guidance problems, those used by NASA, who allowed a lot more freedom for modifications, achieved an outstanding level of reliability. In 1966, Douglas was proud to report that of the 189 Thor launches, all but 9 had been successful. By this point, Douglas had also produced the S-4B, which was the third stage of the Saturn V rocket used in the Apollo Moon program. It also formed the foundation for Skylab, which was the only space station built and exclusively operated by the United States. But along with producing various missiles and launch systems, Douglas also got involved with the development of bombs, underwing pylon systems, avionics, and ejection seats. The company went through a period of huge diversification between 1948 and 1966, one that started from a need to keep the company afloat in a time of reduced sales, and that ended with it having far more projects than it could manage, and, when coupled with the high cost of its airline projects, would have disastrous results. But putting that aside for the time being, we'll take a look at the rest of the company's history first, before we get to the chaos that unfolded in 1966. By 1950, military contracts once again formed the bulk of the company's business, accounting for approximately 87% of all sales.
Though the DC-6 had proven to be popular, it had not been enough to offset the combination of a post-war slump, reduced military demand, and ever-increasing development costs. 1947 had been a particularly bleak year when the company posted its first ever loss of $2.1 million, and its workforce had shrunk to approximately 1/7 of its World War II peak. By the time the Korean War broke out, the company was back in the black though, and a big part of this was thanks to the C-124 Globemaster. Though it looked like it had been stung on the nose by a bee, this large cargo hauler and troop transport soon became the standard airplane of its type to operate with the US Air Force. The combined effects of the Korean War and the development of the Cold War in general soon led to a rapid increase in military aircraft production. Existing World War II designs, which had been sent off to Korea in a panicked hurry, were soon joined by Douglas A-1 Skyraiders, F3D Skynights, C-118s, the militarized version of the DC-6, and the aforementioned C-124. Additionally, work was well underway on the development of the A-3D Skywarrior, which was a jet-powered strategic bomber, and work was also underway on the F3D Skyray, which would become the first US Navy aircraft that could achieve Mach 1 in level flight. Though it would never see combat, arriving too late for the Korean War, the Skyray was a deeply striking design, and one of my personal favourites from the early Cold War period, so definitely expect to see an in-depth video on that particular aircraft in the future. The sudden influx of production orders meant that by the mid-1950s, the Douglas facilities were once again operating near their maximum capacity. Santa Monica continued production of the DC-6 and began mass production of the military transports. Long Beach worked on the C-124 and the Douglas B-66, and El Segundo went back to its old trick of producing naval aircraft in frightening numbers, being responsible for the production of the F3D and F4D fighters, as well as the AD-1, soon to be renamed as the A-1, the A-3D, and it was also tooling up for the production of the A-4 Skyhawk. The A-1 Skyraider and the A-4 Skyhawk were by far and away El Segundo's biggest success stories. Douglas would produce just under 3,200 A-1s, with the type forming a significant chunk of its entire post-war production, and just under 3,000 A-4 Skyhawks would be built under both the Douglas name and then later on as McDonnell Douglas after 1967. The years immediately following the Korean War were ones that once again saw the Douglas Company experience healthy financial growth. Net income grew to $18 million in 1953, and then doubled again to $36 million in 1954, while employment gradually increased from 25,000 up to 71,000. By the end of 1953, Douglas had a record backlog of just over $2 billion worth of aircraft on order, and it would spend the rest of the decade in a very strong financial position. But not everything was as rosy as the numbers would make you think, and the 1950s would mark the beginning of a quiet, gradual series of events, some highly obscure, some glaringly obvious in hindsight, which individually did not always amount to much, but collectively would seal the company's fate just a decade later. Now, the downfall of the Douglas Company is a relatively complex topic, but broadly speaking, it boils down to three key things. Firstly, there is Douglas's reluctance to initiate the development of a jet-powered airliner, and this allowed his competition to get ahead, and the company was forever playing a game of catch-up. Secondly, the company's luck ran out when it came to securing large military contracts, which left it financially vulnerable to potential cost blowouts from its commercial designs. And thirdly, the company's structure and its culture became disjointed, particularly after Douglas Jr took the helm in 1957, and this led to poor interdepartmental communication, which ultimately led to financial chaos. All of these things more or less happened simultaneously as well, which really didn't help things, but Now, in this video, we're going to look at them in order of topic rather than chronology, so that I'm not bouncing between 3 different points of discussion every minute or so, which would probably make this video far too chaotic to follow. So, we'll start with the airliner problem, as that was technically the first of the 3 to really arise. And this begins with the Douglas DC-7. This would be the last piston-powered airliner that the company would produce, and in fact it was one that Douglas himself didn't really want to produce either. By the early 1950s he had already given thought to the idea of a jet-powered airliner, but he wasn't yet ready to commit. Although the US military had rapidly transitioned into the jet age, Douglas believed that the commercial market would take much longer. He believed that jet technology was still too expensive to allow airliners to be competitively profitable, and he believed that the industry in general needed to conduct more research to make sure that jet airliners were safe. They would, after all, fly higher and faster than anything before, requiring more advanced pressurized cabins, avionics, fuel systems, etc., and all of this added many more potential points of failure. Because of this, Douglas hesitated to begin development work on a jetliner, despite learning of the development of the de Havilland Comet, and the company only conducted quiet, low-level research. For his part, he was more than happy to continue sale of the DC-6, which was proving to be exceedingly popular. But at the same time, several airlines, particularly American airlines, were insisting upon an improved follow-up. They wanted something that could do a non-stop transcontinental flight between New York and LA in under 8 hours, and that was something that the DC-6 simply couldn't do. Though he initially resisted them, the heads of American Airlines and Pan American eventually convinced Douglas to produce one last piston airliner. Now, Douglas was resistant to this, mostly because it would force him to use the Wright R3350 duplex Cyclone, which was the only engine that was powerful enough and available in quantity. This was the same engine that powered their successful AD-1, but it had brought the company considerable headaches. This was in fact nothing new. This same engine had also powered the B-29 Superfortress, and it too suffered from a litany of engine problems. A lot of this stemmed from the fact that they frequently overheated, a result of putting a lot of power into a relatively small and complex package. But American Airlines were insistent, and Douglas eventually formalized production of the DC-7 after receiving a contract of sale for 25 to be sold to them as soon as it was ready. The prototype DC-7 first flew in May of 1953, and it entered service with American Airlines in November of the same year. Later on, it was joined by the DC-7B, which was a longer-range version designed for Pan American that could carry up to 100 passengers, but the company struggled to find buyers overseas. This changed with the DC-7C. This was also designed for Pan Am, who now wanted an airliner that was capable of making non-stop transatlantic flights to Europe. This model had more powerful engines, and an extended wingspan to allow for larger internal fuel tanks. It began flying in 1956, and it became the first airliner that was capable of reliably completing transatlantic flights, both to and from Europe, as prevailing winds had always made the westbound flight far more challenging. Its ability to make the Atlantic crossing reliably soon resulted in export orders flowing in from the various European carriers, with KLM being the biggest customer immediately ordering 15. Though it was proving to be a successful design, and in many ways it was viewed as the pinnacle of the piston-powered airliner, only 338 DC-7s were built, compared to just over 700 of the preceding DC-6. As Douglas had feared, the Wright duplex Cyclone proved to remain a highly recalcitrant engine, and numerous mid-flight engine failures hurt its reputation. Some airliners retired the DC-7 after just 5 years of service, whilst retaining their older DC-6s for considerably longer. Additionally, for Douglas, the DC-7 was considerably more expensive to produce, and this, combined with all the engine problems, meant that the type was a net loss for the company in general. In fact, Harry Strangman, who was the company's vice president of finance at the time, had remarked that if it wasn't for the military aircraft being built by the El Segundo Division, the company could have well faced bankruptcy due to the DC-7's costly development. But cost was not the only thing that curtailed the production of the DC-7. The bigger factor at play was the true emergence of the jet airliner. Though the Comet was already in service on the other side of the Atlantic, Donald Douglas and his chief engineer Arthur Raymond were still hesitant to fully commit to an all-jet commercial transport. Although the company now had significant experience in developing jet-powered aircraft, Douglas knew that the airline industry as a whole currently operated $1.5 billion worth of piston-powered aircraft, and he doubted it could stomach the financial burden of a rapid transition. And in his defense, this was an opinion that many airliners shared. Instead, Douglas found himself in favor of meeting in the middle, and he allowed the company to begin several design studies for a turboprop airliner instead, one of which being a heavily modified DC-7. However, in secrecy, he also initiated a secret project in June of 1952 to work on designing a pure jet-powered airliner just in case, though he still found it doubtful that they should fully commit to the idea until several more years had passed. The fatal accidents involving the de Havilland Comets in 1954, which led to the type's grounding pending investigations, seemed to confirm Douglas in his reservations, but now an old rival had come back to haunt him. The Boeing Company, though well known for its production of bombers during the Second World War, had been thoroughly beaten and embarrassed in the competition to develop commercial piston-powered airliners. This had always been a bit of a sensitive subject for Bill Allen, the president of Boeing since 1945, and who had worked for the company since 1930. Boeing had gained experience in producing large jet aircraft, with the Boeing B-47 Stratojet and the B-52 Stratofortress. And with the piston engine market so thoroughly dominated by both Douglas and Lockheed, Bill Allen knew that his company had but one choice. It had to take its experience in building large jet bombers and gamble everything on building the world's first successful jet airliner. The result was that Douglas, and many an airline executive for that matter, was considerably shocked when Boeing unveiled its Model 367-80 in July of 1954. Douglas was shocked because he was expecting Boeing to unveil a new prototype fuel tanker, something that his company was also developing as part of a competition for the Air Force. He had not expected Boeing to take a $16 million gamble, one which would break Boeing if it backfired, to jointly develop a brand new jet airliner as well. But they had, and both the Air Force and the airline industry suddenly really liked what they saw. The immediate interest in what would become known as the Boeing 707 forced Douglas to fully commit his company into the jet airline market, lest they lose their relevance and dominance in this field. This led to the rapid development of the Douglas DC-8, which would become the company's biggest financial investment. The need for the DC-8 to be successful was then further highlighted when Douglas lost out on an opportunity to produce a fuel tanker for the Air Force. This was a particularly bitter blow, as it had been expected that the Air Force would split contracts between both Boeing and Douglas, as the Air Force was calling for several hundred of these tankers to be built over a relatively short time. But the work was given to Boeing exclusively, and this allowed Boeing to absorb much of the 707's development costs with lucrative military contracts. After round-the-clock development work, Douglas announced the DC-8 program publicly in June of 1955. Though Boeing now had a considerable head start, and Douglas expected the 707 to enter service a full year before the DC-8, there were some advantages to coming second in this particular race. As the DC-8 was still in many ways a paper airplane, merely existing on the drawing board, it gave the Douglas sales team an opportunity to go out and speak with various airliners and find out what they specifically wanted in a jetliner of the future. It also gave them an opportunity to ask the airliners what they liked and didn't like from the competing design that was being advertised by Boeing. Though many airlines gave conflicting answers, some of which could never be entertained, one big result was that the DC-8 would be designed to have 6 abreast seating, in 2 rows of 3, and this gave it an advantage over the 5 abreast seating arrangement of the Boeing 707, which had a row of 3 and a row of 2. Douglas was also able to use larger and more fuel-efficient engines, which had not been ready for Boeing at the time, and this made the DC-8 a very attractive alternative, even though it wouldn't get on the scene first. The result was that in October of 1955, United Airlines, who had been tipped to go for the Boeing 707, instead placed an order for 30 DC-8s at a cost of $175 million. Not long after this, Boeing made a last-minute and costly decision to redesign the 707, increasing its wing and fuselage to match the DC-8's capabilities, and the ridiculously and expensive competition between the big airliners was well and truly on. The DC-8 program was as much of a gamble for Douglas as the 707 was for Boeing. It cost twice as much to develop and produce when compared to the DC-7, but it was expected to produce triple the revenue in commercial operations. This was in part thanks to a much lower operating cost per mile thanks to the jet's higher speed, and because of this, the DC-8 was predicted to be almost 25% cheaper to operate than the DC-6. By the time the first DC-8 was ready for its maiden flight, the first 707s, as predicted, were about to enter service. But the race between Douglas and Boeing was still neck and neck. Orders for both companies were beginning to pile up. Although most airliners were reluctant to invest heavily into jets, as they were considerably more expensive, they also knew that if their competitors did it first, they would be doomed. And so, even though most of the airline industry wasn't quite ready to go to jets yet, most of them were essentially forced to do it anyway. And so, once again, the demand for a new, expensive, and quite experimental airliner once again exceeded Donald Douglas's expectations. He watched the DC-8 make its maiden flight from Long Beach on May 30th, 1958. It was a significant year for the company. It officially signalled its entry into the world of the jet airliner, and it was also the first full year where Donald Douglas wouldn't manage the day-to-day running of operations. That task now fell to his son. In 1957, Donald Douglas Jr. was made president of the Douglas Aircraft Company. He'd been with the company since 1939, gradually moving up through the ranks. His earliest work was on the development of the C-54 transport. Then he'd worked on various experimental projects, eventually being responsible for test flight operations, and he became the director of the company's research labs and testing division in 1949. 2 years later, he was elected as vice president of the company, and in 1953 he became a member of its board of directors. In many ways, Douglas Jr. was like his father. He was a hard-driven young man who was passionate about his work, and, like his father, he had developed a love for the sea. In 1932, he had earned a silver medal at the Summer Olympic Games in the 6-metre yacht class, and in later years he owned a successive series of fine sailing craft. But, in many other ways, the two men couldn't be more different. Senior was quieter and more reserved. Junior was more extroverted and sociable. Senior had patience, perhaps too much patience at times, and his son was the opposite, passionate and sometimes quick-tempered. The DC-8 project was a prime example of their differences. Don Jr. had pushed for the development of a jetliner as soon as it was feasible, believing that speed would be the deciding factor in the commercial market of the 50s and 60s. But old Douglas felt that it was too risky, and he'd adopted a more conservative and incremental approach, with the appearance of the Boeing jetliner forcing his hand. This conflict over the future of the airliner resulted in many arguments behind closed doors, but despite their differences, the two men would ultimately support each other. Don Jr. put his full effort into the development and testing of the DC-7, despite thinking it a waste of time, and Douglas Sr. did not impede the various design studies that were initiated in the 40s and early 50s to explore the possibility of jet-powered commercial transports. Their unity was not merely from a common desire to see their companies succeed, despite their diverging visions on what that success would entail, but because they had recently found some common ground, besides a love of sailing. Though the two had nearly disowned each other over Don Jr.'s marriage before the war, they had now been united by divorce. Don Jr. and his wife had split not long after the war, and after a long estrangement, Donald Douglas and his wife Charlotte went through a hotly contested and painfully public divorce in 1953. Like many divorces, it essentially split the Douglas family down the middle, with the 5 children essentially being forced to take sides. But Donald Douglas Sr. was very surprised to see his hot-headed son joining him. Don Jr.'s steadfast and unwavering support of his father during the long, drawn-out proceedings did much to repair their relationship, and despite their creative and personal differences, Douglas would be equally supportive of his son when he handed the reins of the company over to him in 1957. But when Don Jr. did take over in 1957, he was inheriting something of a poisoned chalice, though he did not yet know it. His father's reluctance to transition into the jet age was not a fatal mistake by itself, but events would now unfold that would seal the company's fate. When Douglas and Boeing were racing to develop their commercial jets between 1954 and 1958, the airline market had been experiencing a period of massive growth. Passenger mileage was increasing by about 15% on average each year, between 1953 and 1957 inclusive, and the economy was growing just as quickly. But when the DC-8 and 707 were beginning to enter service, between 1958 and 1959, the situation had changed dramatically. Airline demand had slumped, and as the 1960 recession began, neither the 707 or the DC-8 had been sold in the numbers expected. This was further compounded by the fact that both aircraft had failed to meet range and fuel efficiency guarantees, which required costly modifications, and this resulted in a further drop in sales. Usually, the year that an airliner entered service, it would coincide with a boost in sales, but when the DC-8 entered service in 1959, only 18 aircraft were sold that year, despite well over 100 being on order. This was bad enough on its own, and it mirrored the problems of the DC-7, whose own development cost exceeded its sale value. But the losses of the DC-7 had been offset by the huge orders for military aircraft that were being built by the El Segundo Division. Now, things had changed, because El Segundo was rapidly running out of work. In 1952, the company had received a contract to produce what would become the venerable A-4 Skyhawk. But little did the division know that this would be the last big military contract it would ever receive from the US Navy. Existing contracts for the F3D, AD-1, F4D, and A-3D were completed respectively in 1953, 57, 58, and 61, and then nothing else really followed. There had been hopes that the promising F5D-1 Skylancer would get a big contract, but it didn't. To make matters worse, El Segundo was also now without its chief engineer. Ed Heinemann, who had been responsible for the company's most successful military design since the late 1930s, had resigned in 1960. He and Donald Douglas Jr. did not get on very well at all, and when Douglas began restructuring the company, he made Heinemann vice president of the company's European division. It was a role that Heinemann neither wanted or was suitable for, and after a brief stint in this role, he left the company for good. The absence of his leadership and strong drive for quality control would soon be keenly felt. That being said, even if Ed Heinemann hadn't been essentially forced out of the company, he wouldn't have had his position for very much longer. Due to the dwindling number of military aircraft on order, El Segundo became unprofitable, and the plant was actually closed in 1962, with production of the Skyhawk being transferred to the Long Beach facility. The problems stemming from the loss of El Segundo was twofold. Not only did Douglas lose many skilled engineers, who couldn't relocate to other facilities, but it had huge financial ramifications. The drop in revenue from military contracts meant that the Douglas Aircraft Company couldn't easily absorb all of the costs incurred by the DC-8 program, of which it had invested $500 million in development thus far, and as a result, the company posted a loss of $33 million for the 1959 fiscal year. It posted another loss of $19 million in 1960, and although it did once again return to profits in 1961, The company couldn't afford to develop any other commercial airliners to complement the DC-8, whereas Boeing was already working on the Model 720. To get around this problem, the company went into business with Sud Aviation, who gave them the sales rights and product support responsibilities for their Caravelle twin-engine transport. Douglas also obtained a license to manufacture the aircraft in the United States, should they secure enough sales to justify the initial outlay. But once again, Boeing beat them to the punch. Douglas did secure some sales to both United Airlines and TWA, but the sales of the new Boeing 727 quickly caught up and then overtook them. Douglas quickly abandoned the idea of selling the Caravelle in the United States, and it soon terminated its other agreements with Sud Aviation as well, viewing them as a waste of money. Now, while Douglas was competing with Boeing for the long-haul market, and while it was failing in the medium-haul market, it did not neglect the potential for a shorter-range design. Indeed, both Don Jr. and Sr. believed that the short-haul and executive market promised to be exceedingly popular in the jet age, particularly if they could sell planes to European customers. With this in mind, several design studies had been initiated in the late 50s and early 60s to explore the idea of a short-range twin-engine transport, and in 1962, the economy, and thus the company's fortunes, had recovered enough for Douglas to start detailed design work on a new short-haul airliner, and this became known as the DC-9. Up until this point, Donald Douglas had always missed the mark in predicting the popularity of his commercial aircraft, but for the first time, his predictions about the popularity of this aircraft would be correct. He expected that the DC-9 would be popular. In fact, it was very popular, possibly too popular. In April of 1963, the company formally announced the development and production of the DC-9, and in less than a month it already made its first sales to Delta Airlines. The company had originally planned to produce approximately 500 DC-9s over a 10-year period, but the type proved to be so appealing to customers that they already had 400 on order within the first 3 years, and eventually just under 1,000 DC-9s would eventually be produced. The DC-9 was produced using a new risk-sharing program, with various parts being built in the United States, Canada, and Italy. Final assembly was done at the Long Beach plant, and here the company now had a massive assembly line, where on one side it produced the DC-8, and on the other side it produced the DC-9. Additionally, the increasing popularity of the DC-9, and thus the increasing sales, allowed the company to finally invest in planned improvements for the DC-8, which had begun to lag behind the Boeing 707 in sales, as a result of the 707 being offered in a variety of different shapes and sizes that Douglas at the time could not afford to match. The result was the so-called Super Sixties. There was the DC-8-61, -62, and -63. The 61 and 63 models offered substantially increased payload capacity, and the 62 had a much longer range. Their popularity quickly grew, with the Super 60s eventually becoming the dominant model of the DC-8. And this, combined with the sudden popularity of the DC-9, meant that Douglas once again had to rapidly expand its production facilities in 1966. And this is where things start to go very wrong very quickly. In 1966, the Douglas Aircraft Company completely lost control of its costs, and in less than a year it would be facing bankruptcy. And this was a perfect storm of contributing factors. Firstly, Douglas had recently lost out on a competition to build a large strategic transport, with Lockheed being awarded a contract to produce the C-5 Galaxy. This all but locked out Douglas from the hugely lucrative market for producing transports for the US military for at least the next 2 decades, and it was now using this aborted project as part of a design study into a new wide-body airliner. This was initially to be a double-decker design, intended to compete with Boeing's 747, which was now in development. And although this would never fully eventuate, instead evolving into the DC-10, it took vital engineers away from the projects to improve the DC-8 and build the DC-9. This meant that the people managing these existing projects had even more work to do, and they were already under a considerable amount of pressure as a lot of them were quite new to the job. Which leads us to the second problem. Between 1958 and 1956, the company had lost a lot of its most experienced managers, across almost all areas as well. Research, development, manufacturing, sales, you name it, there had been a serious changing of the guard. Many of their replacements were still adjusting to their new positions, or were sometimes better suited elsewhere, and this made the company very top-heavy, with poor communication between departments. One big consequence of this was that the Douglas sales team was signing up airliners left, right, and centre without fully appreciating that the production facilities had no way of keeping pace with the rapidly expanding demand. This meant that the company had to very quickly organise new production facilities, build new tools, and hire and train more workers. And this all cost a lot of money, and it also led into the next big problem: sourcing said manpower in the first place. As orders for the DC-8 had declined during the 1960 recession, and as the supply of military contracts all but dried up, the Douglas workforce had shrunk down from 27,000 to just 7,500. Now, all of a sudden, the demand was back, and that meant that the workforce had to rapidly expand. Now, on its own, this was a big problem as it was, as Douglas had to rapidly hire and then train thousands of workers to produce its aircraft. In many ways, it was similar to a situation that the company faced at the start of its involvement in the Second World War, but at the same time it was vastly different from the days of the Second World War because the aircraft being built back then were much more simpler. Unlike before, the company didn't just need people who could operate a simple rivet gun, they needed skilled workers to produce the complex electrical systems, install the advanced turbojet engines, build and test the pressurized cabins, the list goes on. And all of this was now further exacerbated by the escalating situation of the Vietnam War. Not only was Douglas struggling to hire new employees because everyone was getting drafted up, but they were losing many existing qualified employees who were also being drafted up. And then, whilst Douglas was scrambling to A, hire new employees, and B, not lose existing ones, the Vietnam War caused an explosion of military contracts. The loss of Ed Heinemann and the El Segundo Division was particularly felt, as orders for the A-4 Skyhawk suddenly increased by an order of magnitude, and the company scrambled to build them in quantity, on time, and most importantly, within cost. The result of all of this was simple. Although the company had a backlog that was now worth $3 billion, it suddenly posted a net loss of $3 million in the first quarter of 1966. By the end of the year, this had blown out to a loss of $27 million, but the situation had become so chaotic that some estimated that the true loss could be closer to $80 million. Because of all of the aforementioned problems, Douglas was now making huge losses on every single aircraft it was building. Everything had suddenly become too expensive. Now, much of this came as a complete shock to both Douglas Sr. and his son, who had announced at the start of the year that the company was, in fact, in the best financial position it had found itself in years, not staring down the barrel of a financial apocalypse. Unfortunately, the communication structure of the company had become so disjointed that they simply weren't aware of many of the problems that had been bubbling under the surface for the past few years. As things rapidly spiraled out of control, Donald Douglas once again took over control of his company, but he was particularly aggrieved to see the board of directors, and many of the senior-level managers, suddenly turn on his son and blame him solely for the company's problems. Rapidly running out of options, Douglas approached the Wall Street firm of Lazard Frères to help him find a way out of their impending financial collapse. The management firm set up shop in Santa Monica, and after a thorough examination of the situation, some of which yielded some truly horrifying figures, they presented Douglas with the ugly truth. His company needed new management, and more importantly, it needed a lot more money, and this meant they had no choice but to seek a merger.
In December, with Douglas Aircraft facing financial collapse, the board held emergency meetings to find a merger partner. Potential candidates included General Dynamics, North American Aviation, Martin Marietta, and McDonnell Aircraft. Later, Fairchild and Signal Oil and Gas also entered into the race. A special committee was formed to evaluate the bids, as it was estimated that Douglas needed $400 million to survive, and much of that required in immediate ready cash. The ideal partner needed a strong credit rating, proven operational controls, and at least $100 million in equity capital. By January, the committee began to hear the proposals. On January the 9th, James McDonnell, head of McDonnell Aircraft, and already the largest personal shareholder of Douglas stock, with 300,000 shares in his name, made the first presentation. McDonnell proposed buying 1.5 million shares of Douglas at $43 per share, though the committee felt this was a bit on the low side, and then merging the companies. McDonnell emphasized his company's solid financial base, which included years of profitable operations and his young, aggressive management team. He also noted that McDonnell Aircraft had already reorganized into separate autonomous divisions, making it easy to integrate Douglas as a new division alongside them. The committee was admittedly impressed with McDonnell's vision and his proposal, but they pressed him to improve his buying offer. On January the 11th, North American Aviation presented its proposal. J. L. Atwood, the company's chairman and president, was a former Douglas employee with deep connections to the company. Speaking as a neighbor offering help, Atwood proposed a stock-for-stock merger. North American would trade 1.2 of its shares for each Douglas share, pending Justice Department approval. He also offered to purchase senior securities issued by Douglas to provide immediate financial relief. North American had a strong reputation as a conservatively managed company, with $2 billion in sales and $500 million in assets, and they had extensive facilities near Douglas's own operations in South California. Atwood's plan appealed to the committee, especially given his long-standing ties with Douglas. However, North American's proposal lacked the large cash infusion that Douglas desperately needed in the short-term crisis. Meanwhile, other contenders like Signal Oil and Gas and General Dynamics also made their cases. Signal offered a $100 million loan, backed by the Bank of America, and proposed taking control of the Douglas board to provide stronger leadership. General Dynamics suggested issuing preferred stock to provide funding, and highlighted its interest in re-entering the commercial aircraft market. However, the committee would quickly dismiss both offers. Signal for lacking aerospace experience, and General Dynamics for uncertainties around its ability to raise capital quickly. During this time, Fairchild Hiller also made a proposal, but offered little financial or managerial advantage, and their bid was dropped as quickly as it was offered. By January the 13th, the competition had narrowed to North American and McDonnell. James McDonnell then strengthened his bid by raising the share purchase price to $45.80, which was above Douglas's market value, and pledging nearly $69 million in immediate cash, which he would raise by personally purchasing a further 1.5 million Douglas shares. The man was clearly eager. He also guaranteed that his offer of immediate cash would stand even if the Justice Department blocked the merger. In private, McDonnell also assured Donald Douglas Sr. that his son would be given a 7-year director's contract, and Douglas himself would be made an honorary chairman of the new company board. North American Aviation refused to increase their original bid, and so the revised offer by McDonnell was approved by unanimous vote on the 13th of January 1967. Government approval swiftly followed, owing to the increased demand for Douglas aircraft in the Vietnam War. The whole process was formalized by the spring, and on the 28th of April 1967, Douglas Aircraft ceased to be, and the new McDonnell Douglas Corporation was officially begun. Don Jr. was brought on as one of its directors, working with them until 1989, and Douglas Sr., per McDonnell's offer, was named honorary chairman. It was meant as a kindness by McDonnell, who had a real regard for his old competitor, but it came with no authority, and Donald Douglas no longer had any control over the company that he had founded 47 years earlier.
The story of the McDonnell-Douglas Corporation is one for another day, but I do want to touch on one facet of Douglas's downfall that is often a cause of contention. At the time of the company's collapse, Douglas Jr. bore the brunt of the blame for its failure, but much of the criticism that was directed towards him was emotional, biased, and often untrue, something that his father deeply regretted. Donald Douglas had managed his company with a firm hand, forming a tight-knit network of individuals across all levels of the company, but in a way he had done his job too well. He had surrounded himself with people that he worked with very well, and who were very loyal to him, but that was it. They were loyal to him. Because of this loyalty, many of the company's old guard viewed his son as just that, a young, impulsive man who could never fit in his father's shoes, despite the fact that he had climbed the company's ranks on his own, with Douglas specifically going out of his own way to avoid any hint of favoritism. Unfortunately, it did not help that the two Douglases were very different in personality, and this led to an inevitable rift in the ranks of the company when his son took over the presidency. People who were used to working with the father did not necessarily find it easy to work with the son. The animosity that grew between the younger Douglas and his father's old cohort led to inevitable failings. Almost all of them were either replaced or simply resigned from personal feeling, and in the end both sides were equally to blame, though Douglas Jr. often received the most of it as the company was his father's namesake. But this alone had not doomed the company, as some people like to say. There were many causes, not least being his father's decision to delay entry into the jet age and giving Boeing a head start. Additionally, even if Douglas Jr. had not taken over in his father's place, it's highly likely that any successor to Douglas himself would have faced some level of resistance once they'd taken charge. The McDonnell-Douglas Corporation would continue to produce many of Douglas's designs for many years. They also carried on the use of Douglas's iconic logo, which went back to the flight of the World Cruisers way back in 1924. It was a logo that Boeing would later inherit when they merged with McDonnell Douglas in 1997. If Douglas ever felt any bitterness about the loss of his company, he never voiced it publicly, and he bowed out with pride and dignity, saying that one should never grow old where one was once great. He often reflected warmly about his company's achievements over the past 40 years, and he spent his retirement sailing his yacht and writing poetry. Donald Douglas passed away aged 88 on February 1st, 1981. At his request, his ashes were scattered over the Pacific Ocean, where he had spent some of the happiest days of his life. Today, many of his aircraft are still flying, and many take pride of place as iconic displays in aviation museums around the world. They continue the legacy of Douglas and his aircraft, and it is a legacy that, as of now, has carried on for just over a century.
As always, thank you all so much for watching, and a big thank you, of course, to the Patreon supporters. I hope you all enjoyed this extended version of my coverage on the history of Douglas aircraft. I admit I was never fully satisfied with the original, and I just couldn't put it out of my mind until it was fixed, so here we are. A big thank you, of course, to our Wing Commander tier patrons, our highest tier supporters, and if you like long content, there is more coming over the next weeks and months, hence the reduced upload pace. It is somewhat hard to make multi-hour videos in the span of just a week. Now, the more eagle-eared of you would have probably noticed that this entire video wasn't completely re-recorded audio. Some of the audio was from the original video, so I apologize if sometimes my voice changes tone and pitch a tiny bit, as my exact vocal layout is slightly different, I guess, from a year ago. I'm also somewhat still recovering from a cold, so that might have dropped my voice by a tone or so, but hopefully it's not too jarring and everyone enjoyed today's endeavor. But as always, thank you all so much for your continued support, and I will catch you all next time. Goodbye.